Hey guys, welcome to the course of blockchain technology. Here we'll be learning about blockchain technology in a very fun and practical way while implementing blockchain technology and learning through visuals and artifacts. So let's get started guys. So the contents of this course, for you to understand it very easily guys, we have divided this course into three modules. So the first module consists of blockchain fundamentals and you will create your own blockchain in this module. The next module consists of cryptocurrencies fundamentals and you will be creating your own cryptocurrency in this module as well. While the third module consists of the smart contracts intuition where you will be learning more about the smart contract and what all we can do with smart contract, and after that as a bonus you will be deploying your first smart contract. So guys, let's get started with the blockchain fundamentals here and right now. So guys, before we start, let us see a plan of attack and what we'll be learning in this section of the course. So we'll be learning about what is blockchain, what's inside a block or the contents of a block, hash cryptography, immutable ledger, P2P network, how mining works, and Byzantine fault tolerance with what is a consensus protocol. While you'll not know all of these terms and terminologies right now, that's completely okay. You just have to sit back and watch this video till the end. You'll learn everything and let's get started guys. So what is blockchain? As the name suggests, block consists of the data or the transactions and all of the blocks in the chain are linked together, hence naming it blockchain. So we'll look into the definition of what is blockchain so that we could understand it better, and let's see what's the definition of blockchain. So blockchain is a distributed, digital, decentralized peer-to-peer database where the blocks are linked cryptographically to each other and new blocks are added through a consensus mechanism. This is the whole and sole definition of blockchain. While you'll not be knowing all of the terminologies right now, as I've said earlier, don't take tension. We'll be learning all of the terminologies. So let's get started, guys. So the terminologies consist of the hash cryptography, immutable ledger, distributed P2P network, mining, and the consensus protocol, guys. After looking at what is a blockchain, now let us see the contents of a block in a detailed manner. So let's get started. So what's inside a block? This is a picture that shows you rough details of what is a block. We'll be looking at the visuals of the block. Here, the block consists of the data, that is the transactions that are going to store in that block, the previous hash, which is null here. This is a rough block. To show you the visuals of the block, let me take you outside of this PPT, guys. So here I am, andersbrownworth.com /blockchain /block. This is a huge credit to him. He has made a visual of a block which is very great and very helpful for us to learn. So yeah, all the credit goes to him. Here is a block. Here you can see the number of a block, that is the first block, the nonce. So for now, you just have to remember that nonce is basically a random number that is computed by the miners to mine a block. Next to the data, you can store anything in this data tab, transactions history, or strings or numbers or any digital documents, whatever you want. And down here is the hash. So here you can see that there is nothing in the data tab while it still has a hash. For demonstration purpose, I'll show you what you can put in the data. Let's say I'll type here, I am. So here I have typed in, hi, I am teaching blockchain technology, and you might have noticed that this color has changed to red. And let me show you one more thing, that after I remove what I have written, so the color changed to blue. So this is the mining of a block. So whenever you change anything in the block, the color changes or the link or the hash changes. So for me to mine this block again, I have to click here the mine button, and here you can see the mining of the block is happening. My PC is slow, so it took time, but it shouldn't take time in your PC or laptop if it is fast. So now you can see, hi, I'm teaching blockchain technology is hard coded in that block number one. The nonce has changed and the hash has completely changed. And the color also has changed to its original color, that is the blue color. Now let me just eliminate this exclamation mark here. Now you can see that the color has also changed and the hash has also completely changed. Now let me mine it once more again for you. We'll learn what is mining ahead in the PPT, but for now let me show you again. So I'll click on the mine button. It is taking its time as usual. Let's wait, guys. So now you can see after the exclamation mark, the block is mined, the nonce has absolutely changed, and the hash also consists 4 zeros ahead of it. So these are the contents of the block, while the timestamp is missing here. So we don't need a timestamp to just demonstrate a block. So yeah, it's completely okay to not have a timestamp here. But in a real world blockchain, you have timestamps. So after we have seen the visuals of the block, so let us now go to the terms and see what is the cryptographic hashing. So cryptographic hashing algorithms, there are many types of cryptographic hashing algorithms, but the four that I've chosen for you is the MD5, means the message digest algorithm 5. It is helpful to create digital signatures. SHA-1, which is a secure hashing algorithm which anybody barely uses. RSA, Rivest, Shamir, Adleman. These are the three men who created this algorithm, and it is used for the encryption key, while the SHA-256 hash, which is the secure hashing algorithm 256 bits, which are real world blockchain users like the Bitcoin, the Ethereums, and many more, guys. So what is cryptographic hashing? You must be curious to know about it. So let me tell you that cryptographic hashing functions generates a fixed length character string from data records of any length. A data record can be a word, a sentence, a longer text, or even an entire file like a PDF documents, Word documents, this video file, and many more files. As you've seen in my previous visual, that I wrote a sentence, a bunch of words, while the hash was the same, the 64-bit characters. That is a SHA-256 hash. So how hashing algorithms work? So you take a plain text string file, unless it is double quoted, it is a string. So you take that file, you put it in a hashing algorithm like the SHA-256 hash, and that hashing algorithms give you hash text like you have seen before, the cryptic long string 64 bits, and that's true. And you can put a file or a video file or anything that has a hash. What is a SHA-256 hash? Let us say a person has a unique identifier of its fingerprints. So you, I, everybody in this world have different fingerprints. That is your unique identifier. So to give the unique identifier to the digital files, SHA-256 hash was created. Means the secured hashing algorithm, which is of 256 bits, was created. So let's say PDF files, MP4 files, your PPTX files, your Word files, they also need some unique identifier. So that is given by the SHA-256 hashing algorithm, and you can see the unique identifier looks a more bit cryptic like this, which is of 64 bits of length. So the SHA-256 hash consists of hexadecimal characters. Hexadecimal characters are start from 0 and ends to F, means from 0 to 9 in digits, and alphabets from A to F. These are the combination of 64 characters. These all hexadecimal characters combine to form a 64 characters, and that is known as a SHA-256. So let us now see the requirements for hashing algorithm. So how should you choose a hashing algorithm if you want to build your own blockchain in a time or so? So the hashing algorithm should be one way. So what's the meaning of one way? I can go from my PDF file to the hash, but I cannot retrieve the PDF file from the hash. Let's say if some attacker gets my hash, so he should not be able to get the file that is associated with the hash, or the text or the strings that is associated with the hash, so it will breach your data. So the first and foremost and the biggest requirement for the hashing algorithm is it should be one way only. The next is deterministic, means I told you in the visual of a block that there is a hash for nothing. Means if you don't write any data in the data tab, so there is a hash for that as well. So if let's say I've wrote something and I want to delete that and want to go to that previous data also, then there is the hash of that as well. It means that the hash never changes. Let's say I want to mine A, the letter A, and I mine that block and I got a hash of, let's say, 1 2 3 4. Now I wrote B, and when I cancel that B and go to A, the hash will be same, 1 2 3 4. That will not be changing. So that is deterministic. I'll let you know in the visuals ahead of what is one way, what is deterministic, and all these things, so you don't need to take tension, and we'll just practice it in more visual form. So next is fast computation. In today's online world, we cannot wait even a single second for that WhatsApp message to hit our notification tabs. So how can you imagine that we can wait for this hashing algorithm to take 1 2 hours to mine or to give you the cryptic hash? That is poorly designed algorithm if it is giving you slow computation. So you need to have a fast computation for this hashing algorithm as well. The avalanche effect. Now let's say I'll give you a basic example. I have written a string hi. It computes me a hash of, let's say, 1 2 3 4 5 6 7. Now if I add one single word, let's say hi, and after that I add a word a, means hi it doesn't make any sense, but I am adding. So higher, and that previous hash will completely dynamically change. It will change, let's say, to AAFFGGH. Yeah, it can change to that as well. And that is the avalanche effect for the hashing algorithm. Must withstand collision. Let's say a attacker or a hacker or somebody who wants to corrupt this hashing algorithm comes and computes that same file again and again and again to basically collide this algorithm or to crash this algorithm. So the algorithm that you're using for a hash should withstand collisions as well, so that your data is safe and no attacker or hacker should get access to your data. So here is a rough photo of what is the one-way thing. So as I've mentioned here, this is the website where we'll be going to see the visuals of the hash, and once again all the credits goes to andersbrownworth.com. You can visit him. So here I am on his website. This is a demo website which shows you how the hashing works behind the scenes for us. So this is a SHA-256 hash. Here you can see that I have put it nothing in this data tab, and I have a hash that starts with E3B0 and ends with B855. You need to remember just these 2 to 4 numbers so that we can see that deterministic requirement of this hashing algorithms. So I'll type here the same string that I've typed before, that is. So here you can see I've typed here, hi, I'm teaching blockchain technology, and the hash is 77D0 and the ending is 99553. So to show you the avalanche effect of this hashing algorithm, let me type just an exclamation mark after my string. See, with that exclamation mark, this hash completely changed. So it is 7EDD and it ends with 090C. So this is the avalanche effect of the blockchain, and you can never retrieve the data from this hash as it is only of the 64 bits, and this can be a whole paragraph as well. Let me show you a demonstration. So basically I'll search on my Google some sample text. So here I am at the sample text website. So what I'll do here is basically copy all of these and cut this and just paste. So here you can see I have not written just one word, two words or a couple of words, but I've written whole paragraphs as well. And here you can see the hash is only 64 bits. Yes, it is only of 64 bits, and for your kind information I can write a whole bunch of books as well and it will be only of 64 bits. So this is the beauty of this hashing algorithms, where you can never ever retrieve the data that is put it inside the data block from the hash given. So yeah, this is the all of the demonstrations of the hash. Hope you understand well. Let's go to the next, that is the immutable ledger. So let us learn now what is immutable ledger through this rough diagram. So first of all, you can see that the Genesis block hashtag 1 means the block number 1 and the block number 2. Here you can see in the below tabs that it is previous hash and the hash. So the previous hash of the Genesis block is as usual null. The hash of the block is 00D. While the block number 1, you can see the hash is something related to its data, while the previous hash is 000D. So there is a linkage between the hash and the previous hash of Genesis block and block 1, and so it continues from the block 1 to the block 2, and from block 2 to 3, 3 to 4, 4 to 5. The hashes and the previous hashes of all of these blocks are linked together, thus forming a ledger and a chain. So these blocks are hence known to be cryptographically linked together to each other, and as you know, if I try to change the data from one bit as well, the hash will completely change and the link will get destroyed, and the blocks that are mined afterwards will not be linked to each other. So how this traditional ledger system work? I have a deed of my house. Let's say I've bought it for just 50 lakh rupees here in India. So what happens that someone in my neighborhood or in my family wants that house as well, and he doesn't want to buy from me, and what he can do, he can just tear the page from the deed, change the name of that deed to himself, or take my false sign on other deeds that I have transferred the house to him, or he can hack the database of the governments, as you know that it is easily hackable, or the government. Let's say the government is against me and the government wants that house from me, so it can very easily change the data from that database, and so that house that was mine is not no longer mine and I am now houseless. So this is a serious concern where you don't have your own privacy, your own rights of that house after having the deed as well. This is a serious concern, and this concern is being solved by our blockchain. So let us see how blockchain solves it. So let's say that these are the blocks. So this is the block number 1, and here some others deeds are being stored. Here is the block number 2. Some other deeds are being stored, and in this block my house deeds are being stored. What happens that after 5 to 10 years, many other peoples have bought their houses and those blocks are also added. But after 5 to 10 years, let's say my own son wants that house from me and I'm not willing to give him right now. So what he does, he is a hacker, let's say, and he wants to cheat the system of this blockchain technology. So what he does, he tries to change this data from that blockchain, and what happens after changing the data, he has to compute the hash. And you know the feature of the hashing algorithm, that if you recompute it, the hash will completely change. Thus, if the hash of this block is changed, it will not be linked to the further blocks. If this block is not linked to the further block, then the hash of this block will also change. And if this block hash changes, then it will not be linked to this block, and this block will also change its hash or recompute its hash. And furthermore, this will also be not linked to this block, and this will break the linkage of all the blocks that are in that blockchain. So now what happens, that it is immutable and you can never change it, as you have to recompute the hash, and the linkage of the blockchain will thus not be valid. So here you can store, let me just clear the screen first. So here you can see that your data is secured and nobody can access to it, or if someone get access also, if he tries to manipulate the blocks, it will be heavy on his side only, and thus it is immutable. So if you think that immutable ledger and all those stuff is just a gimmick and anybody can just change it, and you know who will know, and all of these things that are going in your mind, so don't get worried. Blockchain has an another feature added, that is the distributed peer-to-peer network. What does this means? Let's say there is a database of Amazon. So what we do, we go to our mobile phones or our PC or laptops and we try to access those server base from its website. So here you can see that all of these computers in the client server network, if they want to access a data, they go to the servers, request the data, and the servers respond to their request. Let's say I want to see a picture of shoes. I go to the Amazon website, I type shoes, and the command that I tap in the search bar goes to the server. The server gives me a tons of shoes with their prices and I can buy them easily from there. This is the client server network. But let's say the server is been hacked. As server serves as a central hub to the data that I want from Amazon. When the load on the server increases, it tends to get slower. While I cannot just trust Amazon or a big organization or institution or some one single person or a leader, I can safely store my data. Let's say I am storing my personal data, my credit card, my passport number, my driving license number, or my banking details into a server of, I'm not defaming any of them or any centralized hubs here, but just taking their names, let's say Uber. So I store there. I don't know what Uber will do with my data because they do not give access to their central hubs or their servers to me. They only give access to what I need or what they want me to show. They don't give all of their access to their server. While in the peer-to-peer network databases, everybody that is inside the network has an access to all of the ledger or the databases that are stored in the nodes or the network. So let's say in the previous example that my child changes the data and the link has been broken. Here my child, or yeah, let's say my child tries to hack this block and tries to change it, and if the blockchain of this node is been tampered, and here all of the 5 computers will get to know that this is tampered because they also have the copy of that same database, and they can verify it easily that, oh, that someone here is changing the cryptographic hash and it is not matching with our ledger. So yeah, there is something wrong going here, and what they will immediately do is they will update the database to this node as well. What my child was going to tamper the data, it will be completely irrelevant. And to change the database in all of the networks, he has to, by the rule, change more than 51% of the network. So here only 6 are there. So you might be thinking that, oh, he can do in 6 in just 5 to 10 minutes or so. But let me tell you that today's world blockchains are not just 6 or so computers. They are lakhs and lakhs and lakhs of computers generating more and more computational power, and it is very difficult for anybody to change that database. So yeah, this is the advantage of distributed peer-to-peer network, as it takes the security of the blockchain technology to a next level. So let us now visualize what is distributed peer-to-peer network through that Anders Brownworth website. So here you can see that I am showing you a distributed blockchain visuals to give you a glimpse of what is happening here. Here is the peer A, and here you can see 3 to 5 blocks. Next is the peer B, which has the same 3 to 5 blocks, and the last one is the peer C, which also has the 3 to 5 blocks. So now what I will do, very quickly I will add all of the data that I want to store in this peer A, and let us now try to change it and recompute it in the peer B and peer C. So let's start. So I'm just writing here hi and mining this block. So here you can see the color is also changing. So here I'm writing blockchain and here I'll write technology. Mine the last block. So now guys, as you can look around, here I've written hi, I am teaching blockchain technology to all of the peers nodes. So guys, every block in this peer has the same nonce. Here you can see block 1 has 79998, while in peer B also you can see it's a 79998, and in peer C also you can see it is 79998. The hashes are also the same. So let's say I am a little mischievous and I want to change this. So I changed H. So I removed I from the high. So the hash is now changed. The linking of these blocks have now been interrupted, and the color has also changed. So now I can just look over this next peer, means peer B, and now here I can see that the hash here is leading with 5 zeros and a 5e, and in peer C as well. So now I can conclude that peer A has something wrong in it, and I will now add I, or what I will do, I will just update the databases of peer B and peer C to peer A, so that all of the contents, I don't have to overwrite it, it will just get updated automatically through an algorithm. I hope that you have learned what is the distributed peer-to-peer network in the blockchain. After we have learned what is a distributed peer-to-peer networks, Now let us learn what is mining and how mining works. So mining is a mechanism whereby nodes called miners validate new transactions and add them to the blockchain ledger. Basically, it means that mining is a process where you need to add a block, and that block is added through mining by the miners. Miners are basically the nodes that are participating in that blockchain network. We have seen mining in the distributed P2P network as well, where we used to mine the blocks. So what miners actually need to do? So miners basically need to solve a complex mathematical problem based on a cryptographic hashing algorithm, so that they need to show the proof of work that they are doing to mine a block. They received rewards as transaction fees and bitcoins or ethereums in rewards. So this is a diagram which shows how mining works. So let's say previous block header is there, new proposed block is there. So what happens? They generate hash. After then generating the hash, if the hash they generated is less than the targeted hash, they will publish the block, add the transactions to the block, and they will fetch rewards and transaction fees from that block. If it is greater than the hash, then what they will do, they will just increment nonce. Nonce, I told you that it is a random number that miners use to mine a block. So just they will increment the nonce by one or by two numbers, and then they will repeat the process again and again, 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 till they get the correct nonce below from the target hash. So now you know that how mining works, and people guys put a lot and lot of computational power behind this mining thing to mine new blocks basically. So what is the mining mechanism? So here is the block, that is the block number 2, the data that is hard coded in that block, the previous hash of the block and the hash of the block with the timestamp of the block. So nonce, because we need to compute nonce and increment nonce one by one. So here let's say all possible hashes are being shown here, the largest and the smallest. So let's say a hash is here, the next hash is above that, because there's incrementing, the next hash is here, the next hash is here, the next hash is near the smallest one, the target hash is between them. So the nonce of 10, the nonce of 25, the nonce of 200, the nonce of 7520, because you just can't say that if here it is 10, here it is 25, thing we don't know, because it is just a random number. You don't know it is going from 1 from 0 to 100 like this, or from 0 to 4 billion like this. You don't know anything guys. So it is just a random number. So here you can see that the target is somewhere here, and our nonce that we calculated is here. So this is the correct nonce I think, and now my block will be mined and I will get some rewards from the algorithm and some transaction fees from the users. So why is mining important? So mining is important for two reasons. The first reason is the monetary benefit of mining. Let's say you receive transaction fees, you receive blocks, you receive bitcoins or ethereum, that has some monetary value. The next thing, that mining requires a lot of computational power, and through that computational power there is a robust system building behind the scenes. I'll tell you why. See, Bitcoin has very high robust system through these computational powers, as it requires lots and lot of electricity to run this Bitcoin system. So not anybody can participate in this mining mechanisms. This also ensures the security and the robustness of the public blockchain. Let's say two Byzantines mean the Romans army need to attack to a city. So what happens that if two of them attack together, there is a chance that they will win over that city or that kingdom. But if they do not attack at the same time, they do not have any chance to win, as the city is able to withstand one but not two of the Roman kings. What happens that General A needs to communicate to General B that the message passing through that city that the day and the time they need to attack on that kingdom. What happens? There are many problems related to this message sending. Let's say that General A sends a message to General B and they lack confidence between them. Let's say General A is not trusting General B or General B is not trusting General A, so they will lose the battle. Next, there is a traitor among the kingdom who is sending false message to General B. General A told that they need to attack on Monday, but the traitor told that they need to attack on Tuesday. This will lead to a loss of the battle. General A sends a message to General B, but General B needs to verify that it has come from General A only and not from somebody else. Whilst there is also the case that the message is passing through the kingdom or the city. The people of the kingdom will attack the messenger or the person who's carrying that message and will try to cheat the message or try to fake the message and send it to General B. So they could not win amongst the kingdom. What happens here? If they coordinate, they are leading to victory. If they don't coordinate, they are not leading to victory. And this is a very huge problem in peer-to-peer systems as well. If you don't come to a consensus, let's say in a distributed peer-to-peer network system, that is our blockchain, some people are not agreeing to some terms and some people are not agreeing to other terms. So this is a very huge problem. What is a solution to this problem? We'll discuss it in the next chapter of this module. So to discuss the solution of the Byzantine fault tolerance and to come to a consensus, we have our consensus mechanism. So what is the consensus mechanism? So the members of a blockchain network need to come to a consensus via consensus mechanisms to make decisions. Let's say to approve transactions, to approve some new changes in the blockchain itself. There are various types of consensus mechanisms. We are at a very early stage to hard cap that these are the only consensus mechanism, as it is never ending process and people will find new consensus mechanisms as they grow further or as it is needed. But today we have two of the most robust consensus mechanisms, that is a proof of work and the proof of stake. So what happens here is, I believe that people learn better through comparisons as well. So what I'll do here, I'll compare you these two robust systems, that is a proof of work and the proof of stake, so that we can learn it better and learn what is a consensus mechanism needs and what are the differences between them. The nodes who use proof of work to come to a consensus in a blockchain are known as miners, while the nodes that come to a consensus through the proof of stake are called validators. Miners requires energy to use proof of work, while validators doesn't require any of these and only required to stake their coins or tokens to become a validator. The cost of participation of the miners is quite high, as they need to buy the equipments and energy to run the system, while the cost of this proof of stake is just the cost of the coins or the tokens that you need to stake. As I have told you earlier, that the proof of work is the most robust, secured blockchain because it has a cost of equipment and energy that provides its the robustness, and nobody can easily go and just change it or easily go and just participate in it, as it requires more and more computational power and it increases over a period of time. While in the proof of stake, it is very scalable, as you just need to stake your coins and nothing else. So you bought some coins and you staked it. Well, let me tell you that proof of work or the Bitcoin protocol or the Bitcoin blockchain that uses proof of work is using enormous energy. Means it is seriously using energy more than some countries. This is a serious issue, guys. The Bitcoin network is using energy more than some countries. While the proof of stake, the network control can be purchased if the blockchain is relatively slow and someone or some party owns 51% of that blockchain. He or she can just manipulate the transactions happening in the blockchain. While this is not true to most of the public blockchains, let's say Ethereum is now shifting from proof of work to proof of stake and naming its token ETH 2.0. What is happening here is that Ethereum is going from proof of work to proof of stake, and now you need to stake 31 Ethereum tokens to participate in the validation process. So 31 Ethereum tokens is roughly around hundreds of thousands of dollars. That is not a piece of cake for every person who is listening to this course and in this world as well. So yeah, it is not true for many of them, but it is true for some small blockchains as well. So what are the objectives of consensus mechanism? So the objectives of consensus mechanism are that it should provide a unified agreement between the parties. It should prevent double spending. It should align economic incentive. Let's say the people who are true to the system or true to the network, they should be rewarded as they get rewarded in bitcoins or in transaction fees as well. So fair, equitable. So it should be fair amongst all the people that are using this consensus mechanisms, like the proof of work and the proof of stake uses it very well. It should be fault tolerant, means it should cover the Byzantine fault tolerance and many more fault tolerances for us, so that we never face any of the situations that people are facing. So this makes us to the end of this module. I hope that you have learned building blocks of blockchain and you will thus implement it. And now we are heading to creating our own blockchain. So yeah, I'll teach you how to do those stuffs as well. And hope that you've learned building blocks of blockchain and now you are fully capable of building your own blockchain ahead. Hey guys, I welcome you all to a new video wherein we are going to just start building our blockchain in Python programming language. So let us start with the video. Now I'll tell you how to install the dependencies that we want to just get started. So first we'll go to Anaconda Python. You need to search this keyword in your Google browser or Safari or Chrome or any browser that you use. I'm using your Brave browser. So what you need to do, you need to go to www.anaconda.com and Anaconda distribution, you need to click that, and after you click that you just need to go for this button, download button. And if you are on Mac, you need to click on this button. If you are on Linux, you need to click on this button. After you click download, just you need to install it in a very simple and easier way. You know how to install things. Just next and finish, and that's off for what you need to do. Install this Postman Canary. So Postman Canary download. So here you can see www.postman.com. So here you need to click on this button and you can click on this sign up for free. sign up with Google or any of your email ID or passwords. So guys, here you can see that I can access all of this in my browser only, so no need to install it. But if you want, you can install it. The installation process is pretty simple. Here you can click on this button and download desktop app. That's very easy. So now what we need to do is, after installing your Anaconda, you need to just open this spider python file, spider python editor, where we are going to create our blockchain on this python project. So what you need to do, first I'll save this project. So it's been saved. So let me now go down and just import some libraries that we are going to use here. So first let me import date time library, which will be used for time. Then I will import my hashlib library, which will be using to use SHA-256 hash in Python. I need to import JSON, and then I need to import Flask. So from Flask, I need to import capital Flask, comma JSONify, so that my file looks great. Then comma request. So these are all my files that I need to just import. These are all the libraries that I just need to import in my file. What you need to do here, you need to type this comment pip install flask equals you need to install 0.012.2 and hit enter. Flask as it was installed earlier only. So this is the comment that you need to make on your terminal, and it will get installed as soon as possible. So here I need to define a class name I will give a blockchain. Then I need to define a function, and to define a function I will define init. So as you know that it is a great practice to just define this init and put a self here, that it takes an argument named self, and I will initialize my self dot chain as a list. So after self dot chain I need to just do self dot create block. So I'm creating a new block here, and parentheses, and with the proof equals 1, and previous hash as it is a first block equals 0. So now my init function is created. I need to create a new function. So now I need to create a create block function. Create block function. It will take an argument self proof and previous hash. Now I need to give the contents of a block. I will pass it as a dictionary here. So first is index. I will leverage the len function here and put self dot chain plus 1, put a comma, and go to the next where I will put the timestamp. So timestamp is basically simple, and here I will write date time module dot date time class, and here I will not write month, year or date. I will just write dot now. So this will give me the current date time when the block is mined, and the next part would be proof. Proof equals proof, or proof is equivalent to proof as it is a dictionary. Previous hash equals previous hash. Okay, something went wrong here. Okay, now as you can see that my contents of the block is completed now. So let me move where we need to append the blocks. So self dot chain dot append is a function here. We'll pass in block here and just return our block. So we have created two functions, the initializing function and then this create block function where we can create blocks. And now we'll create a new function, namely that will be get previous block, where I'll pass in the parameter as self, and I will just write return self dot chain and indexing it as -1. So now you can see we have created three functions. Now guys, in this class blockchain we need to make a proof of work function. What is proof of work? I have defined you earlier that proof of work is basically an hashing algorithm with the Bitcoin blockchain uses, and we will also use this in our own blockchain. So let me type proof of work. It will take two arguments, self comma previous proof, wherein now we'll define this whole function. What will it do? So I will type new underscore proof and initialize it to 1. Now what we'll do, we'll just say check proof, which is going to check all of these proof, and we'll by default type it to false. Then we'll create an for loop, then we'll create a while loop wherein while check underscore proof, which is a variable, is is false, that hash operation equals hash, to import a library here, hash lib dot sha256. We need to now minus new proof minus previous proof. But this is very easy guys, anybody can just uh, increment the blocks or make the blocks very easily by mining this. So what we need to do, we need to change the difficulty here. We need to just multiply it by 2, means it's power it by 2, and then power it by 2. Then what we need to do, one more thing is that we need to just convert it into string so that our function sha256 function recognizes it. And now when it is done, I have stringified my proof of work. Now what we'll do, dot encode will literally convert it into string, and then I will put dot x digest and pass it as a function here. So after writing this, now we just need to check a condition that if hash operation, need to check that its first four characters are equal to quote unquote 4 zeros, and if it is, then we will pass that check proof equals true, and else if not, then what we'll just do that we'll just increment this new proof by 1. So new proof plus equals 1. What is this plus equals? It is an implementation function. It only means that new proof equals new proof plus 1. So it means simply this, but to make it shorter and sweeter, I would like to use the increment function here. So here equal to, so equal equals to, and here I shouldn't be calling the function. So now as you can see that my code is completed and my all the functions have defined it very easily. So I'm now creating a new function, that is the hash, that is a hash function. It will take two arguments, self and block that we have created here. Where is this block? You know this block we have created here. So it will take two arguments, and let us now create it. So what this hash function will do, that is hash function will take will JSONify our whole blocks hash and will show it in a more cryptographic hashing way. So we need to define our new variable here, encoded block, which is equals to JSON dot dumps. This is a function of JSON, and here we need to go for block sort keys. Sort keys equals true, and then we need to encode this block so that we can get it in a good format. Now after writing this line of code, we just need to return this. So return, in the hashref library I will use the sha256 function, and with that I will use that encoded block that we've created here. So encoded block, this variable, and we'll show it in a hexadecimal format. So we'll use this function hexadigest, and now we've completed our hash function, and we'll move to the next function, that is the is chain valid function. The parameters that we're going to check here is self and the chain, so that we verify that our chain is correct and it is not being tampered yet. So what we need to do here is that we need to check two conditions, that if our previous hash of the previous block is stated correctly in our current block at the previous hash tab, and the second thing we need to check is that all the zeros in our block, let's say there are four zeros starting and they are correctly placed, means that our cryptographic hash has starting four zeros and it is correctly placed in all of the blocks in our blockchain. So we need to just take these two things. So let's get started. So here I will write previous block, which is equals to chain at the index 0. So we start at an index 0 chain, and I will write here block index which is equals to 1, as we started it from 1. So now what we'll do here is that we are going to do a while loop here, so that it iterates over all of these chains and check whether our condition is true. So while, we'll check this block under index function, block underscore index, which should be less than the length of the chain. So means that chain, so means that it should be less than this. and we will iterate it till this, and block which is equals to chain till the index of block underscore index, which is the variable here. And so now let us put an if condition in this while loop that will check over this if condition, and if it returns false then our chain is invalid, and if it iterates over this if condition then means it is true. So if block of previous hash that I've stated here before, so previous hash I'm using this uh, key of this dictionary here which I've stated here in this create block function, and I'm using this block of that only. So previous hash is bangs equal, bang equals means not equals, that is self dot hash function that I have created here, and I'm going to leverage it now. So self dot hash, and the block I'll use it the previous block function. So the previous block variable that I've created, if this not equals to this then return false, then return false. I need to first give myself 2 to 3 variables, that previous hash, previous proof. So previous proof is equal to the previous block, that the variable and the hashing function of that, so a hash, and the proof function of that, so proof, and the proof equals block proof. So what I need to do here is that copy this statement, this hash operation statement, and just copy it here and once again paste it here, and here I need to make some changes. It is not new proof, it is just proof in this case, so I need to make proof, and now I am good to go here. So next I'll put an if condition. So if hash operation, hash, this variable hash operation at an index of 4 means 0 1 2 3 is bang equals to means not equals to 4 zeros, then what I need to do is that return false. And if this happens, I need to go to the previous block and state it as block. And the next thing I need to do here is I need to increment the block index, so plus equals 1. So now you get this, that here I'll definitely go through this, that this function is quite a lot big and quite a lot to consume in your mind. So it's very simple. So we have created is chain valid, so previous block, and we have initialized it with a chain of arrays 0 starting at the array 0, and we have put the block index as 1. So while this block index is less than the length of the chain, then block and block equals to chain of block index. So if this previous hash is not equals to hash of the previous block, then you have to return false, means the linkage is not there. So how it can be a blockchain? And the next that it is considering is that same thing but with the cryptographic hash. So if the cryptographic hash doesn't contains 4 zeros in the front of it, let's say 000, and all of the hexadecimal characters, then you have to return false again. And so thus the previous block equals to the block, and the block index will increment it by 1 until this condition is valid. So now let me just, if If everything is ready and our block passes the while loop, then we need to return true as well. So now you can see that we have completed this create a blockchain, and now we'll go to the next thing, that is mining a block. So mining a block is very interesting, where we'll interact with our blockchain. We have created a block. Now we are going to mine a block. So for that we need to create our first web app. We'll create our first web app through Flask. As you have imported here, you can see in the above tab that we have imported Flask from Flask import Flask, and here we are getting a warning sign as well that we have not used any of the libraries that we have imported. So now is the time that we'll use them. So to create an instance of the app in a Flask, we need to write app equals Flask and a parenthesis with name as like this written. Now we created our web app successfully in the class, and to create our own blockchain, so what we need to do is that we need to type in blockchain equals the class where that we have created in the blockchain. We'll leverage that here now, and we need to just start with our mining block function. So mining a new block, and so we are going to first mine our block through this mechanism. Let me take you to the Flask quick start guide. We are at the Flask quick start guide. So this all is the code that we need to write to build our application web app. So here you can see I've created the instance of an app with app equals to Flask name, and now I need to create the route function of that web app. So I'll start with that first. So at the rate app dot route, then we'll put a parenthesis under that single quotes, then forward slash. So this is the basic route that we are going to create, but we need to mine a block here. So I'll write mine underscore block, and now I'll put a comma here, and we need to get the methods as well. So method is a function where we'll define the methods that we are going to request from here. So here is the method get method. We are going to use get method, but if we do not describe this get method also, we are still good to go. So what we'll do here, we'll create a def function with the function name as mine block function, mine block. So mine block function is here, and what now we is to do is that let's start writing our own function here. For this first, so previous block equals blockchain dot get. Here we are going to get the files of the previous block that we have created the function. If you remember from here that we have created a get previous block function which used to give us the previous block. So this we are going to leverage here now, and now we need to make the previous proof as well. So previous proof, which is equals to previous block, and here okay I messed up something, so no tension. Previous proof equals previous block, and here in the indexation we will write as the leveraging, we are leveraging the proof function from here. So now we are going to use this function, this variables. So proof equals blockchain. Why are we writing this blockchain here every time that we are using this variable here, that this variable is assigned to the class that we have used above. So instead of using that class again and again and again, we are using this variable, which is pretty more easy for us to use. So blockchain dot proof, proof of work, and here is a function proof of work where we'll use the previous. So here you can see that we have used the previous proof here, and now we'll create another which is the previous block equals blockchain, which is a variable dot hash. So now as you can see that we have created more of the variables that we are going to need. So here now we need to create a block variable as well. So block equals blockchain dot create block. So now we are leveraging here a function that uses this, the proof and the previous hash. So here our function is completed. So now we need to write the response. So response, why we are writing this response? To get the things that we need from the get request of our Flask. So we'll write the response as a dictionary here, message that we need. So message, message we are going to write here as congratulations, you have successfully mined a block. So here I have written the message, and now let me write here as index. So here I need the index of the block. So the index would be block and index, and the next thing would be timestamp. So timestamp here, then how we will leverage our timestamp? So we'll call it from previous one here, the timestamp. The next parameter would be proof. So same thing, block, proof, then comma, then next would be previous hash, and here it would be block, and here previous hash. So as you can see that I have completed this response part. So now what I need to do is that return JSONify response, comma 200. So why this 200? So 200 is basically the OK status code in the HTTP protocol. So we are going to use that and leverage it in our code, so that if everything is all right, it will just tell us that it's all right and we need to go ahead with this. So I have made an explicit typo here that I have written your previous block. Instead, I should have written your previous hash. So if you have caught it before, so yeah, well, I'm sorry. So yeah, we also make sometimes mistakes. So it's previous hash, and now I'm not getting any kind of error. So yeah, the last part of this remains, that we need to create the getting full blockchain. So guys, now I've created the mine block function with that app.route, where we are going to see that in the server. So now let me just start with app.route, and let me explicitly type the forward slash, and I am going to get the chain, means get the length of the chain at the end, and the method would be get instead I don't need to write the method function, but for us to remember that we need to write or there is a method, so we'll write get. So that's not of an issue here. So now what we'll do, def will define a function get chain here, and that's a function. We explicitly put this indexation because indexation is not coming, and in Python you need to make sure that you are at the correct indexation. So let me pass in the dictionary as previous. So the first we need as a output is the chain, so chain function, and this is simple. We'll leverage this blockchain variable dot chain, means dot length of that whole chain here, and now we need to get the length. So length th, and here I will write blockchain, same thing but under a length. So length function, so blockchain with this is an inbuilt function length, so blockchain dot chain ka length. And so here we have completed this, but now we need to return. Okay, here also indexation problem is there, so that's of an issue. So I need to be very sure about my indexation here. If indexation is not right, I will get many errors. So JSONify response, so response here, and again with that code 200. So here I am going to tell you that we are done with the code of building a blockchain here, and so now we'll go to the part where we need to interact with a blockchain. So let's get started in that block. And here I'm getting another warning that flash.request is imported. So I don't think so that we'll need this request, so I'll just omit this and once again save my file, and now we are good to go, guys. So now after this one line of code, we are going to start to run our app. So let me take you first to the Flask. So here you can see in the Flask quick start guide, while coming down you can see that our host is 0.0.0.0. So we copy this first, so host equals 0.0.0 copied here, and now let us come here and write the line of code app.run, and in here we have to pass two arguments. The first one is that host one, so here you should be careful that this host should be in strings form or in single quote, and the second argument should be the port. So port equals 5000. So here you can see where this 5000 came from. Let me show you here that it is 5000 here, and also somewhere it must be written that the port is 5000. See here the localhost is 5000 here. So yeah, the port is actually 5000. To save this file with control.save, and here you can see that we need to be in the same directory as that our folder is there, so this is auto save and here file name is there. So what I need to do here, first I will first select all of this code and just run the file. So fingers crossed, and I'm running the file now. So as here you can see that it is running. I can just go to my Postman canary and paste a get request here. So I just need to copy these lines from here and just go to my Postman canary and just paste it here, and just type mine underscore blocks and just click enter, and what I'll get is here this. So I'll get index 2, the message contact congratulations, you just joined a block, and previous hash is my this number, the proof, is 533, and the timestamp I'm going to get this one. So yeah, this is a screenshot of it, as my internet is not working currently, and so I need to work with screenshots only. But the code is correct. You can just implement it and create your own blockchain. And the other request that I need to place in this postman canary is that get chain, get underscore chain. And so when you click enter here, you will get to this one. Here you can see the get chain photograph, where chain is implemented here, and the index 1, previous hash is 0 as it is a genesis block, proof is 1, timestamp is this, while the index 2 will also be there. So what you can do, you can play with this chain. You can further go ahead where you can just mine 2, 3, 4, 5, 6, 7, 8, 9, how many blocks you want to mine, and just get the chain to get that block. And now you have successfully created a blockchain, and you can just now implement it with cryptocurrency as well. So yeah, that's all for this module, and hope so you've learned building a blockchain in Python as well as in JavaScript. So yeah, adieu, bye bye. So I welcome you all in this new module of the course, that is the module 2, which is the cryptocurrency fundamentals, where we are going to see all about the basic building blocks of cryptocurrencies, and we are going to build our own cryptocurrency as well. So I'm very excited with this module as well. So let's get started in this video. You need to watch this video till the end. So what is a cryptocurrency? You might be thinking of, well, what's it? So let me explain you what is cryptocurrency. Cryptocurrency is a digital money created from code. Yes, you can create your own digital money from coding. So the cryptocurrency economy is monitored by a peer-to-peer internet protocol, which is decentralized and distributed as well. So the cryptocurrency economy is monitored by a peer-to-peer internet protocol, which is decentralized and is stated on the blockchain. Cryptocurrency is an encrypted string of data or a hash encoded to signify one unit of currency, which is hence it is known as cryptocurrency, and it can be used in various purposes like store of value, like P2P trading, or transferring money from one user to another's, and so on and so forth, guys. So some examples of cryptocurrency are Bitcoin, Ethereum, Ripple, means the XRP token. So what all these cryptocurrencies are about, let me explain you in short. So what happens, there is a blockchain. Let's say I'll take an example of Bitcoin. So in Bitcoin blockchain or in Bitcoin network, you can transfer Bitcoins, means the actual coin, through that network who is participating in the network in peer-to-peer manner, so that he or she can receive those bitcoins or you can send them bitcoins. So to participate in the network, you need to send or receive bitcoins, while in Ethereum you need to send the ether tokens, while in the Ripple blockchain you need to send the XRP tokens. So this is basic of cryptocurrency. We are going to go into details of what are cryptocurrencies. So sit back and watch till the end of this video. So what is Bitcoin? You might be thinking, oh, what is this Bitcoin and all of these things? What's the hype around in this whole world about Bitcoin? So Bitcoin is just approximately 13 to 14 years old. Bitcoin was invented in 2009. The Bitcoin white paper was released in 2009 by Satoshi Nakamoto, who is not known till now that who is that person or a group of person is. He is just a identity that has taken named Satoshi Nakamoto. So what happens here is Bitcoin is a decentralized digital currency that can be transferred on the peer-to-peer Bitcoin network. So as I've explained you before, that Bitcoin is decentralized means nobody controls over it. Digital currency means it is fully digital, no backing of it is there. Let's say our currency that we use, let's say we use US dollars. So what happens is that the banks, that the World Bank has some reserve for this US dollars that is pegged to that reserve. The reserve may be gold. So let's say a bank has gold and it can now print US dollars worth of that gold, not more, not less than that. But banks they do print more, then it causes inflation as well. That is another topic we'll cover in it in other videos. But here you need to understand that Bitcoin is decentralized, it is digital currency, it can be transferred to anyone. Let's say party A, me, I want to transfer some bitcoins to my mother, party B. So what I have to do now is that I have to take my mother's bank account, transfer some money from my bank account to hers bank account, and then the bank plays the intermediary role in that. I want to transfer some money to international borders as well. So what happens is it takes more than 5 to 7 days to just process that money transferring, and also they charge me more and more fees as transaction fees to process that money. So what happens now is if I want to send some Bitcoin to someone staying outside of my country or my locality, I don't need to pay any extra transaction fees. The transaction fees will be same. He just need to give me his Bitcoin address where he will be storing all of his Bitcoins, and I can just transfer him simply from my wallet to his wallet address. So let me give you a detailed instruction of what is cryptocurrency, altcoins and tokens. So here I am in the coin market cap website where we are going to look about what's cryptocurrencies, altcoins and tokens as well. So here you can see that everything that is under the cryptocurrency is not namely the cryptocurrency. Bitcoin is there and the market cap of Bitcoin is just woofing $580 billion. That is insane amount of money that is thrown into Bitcoin on the past 13 to 14 years now. You can see that the circulating supply of Bitcoin is 19 million Bitcoins, while the total Bitcoin that are going to be there in this whole world is just 21 million Bitcoin. I am going to tell you this in the next slides as well. Here you can see everything except of Bitcoin is altcoin. Let me tell you, Ethereum is an altcoin. You can see your BNB is an altcoin, Cardano, XRP, BUSD, Solana's, Polkadot, Wrapped Bitcoin, Tron, Dai, Avalanche. Well, here comes Shiba Inu. Shiba Inu is not an altcoin, a token that is built on top of the Ethereum blockchain. In the next coming modules, means in module 3, we are going to deploy our own token on the Ethereum blockchain, which will be named as the fighter token. You need to watch that video as well if you want to deploy your own token in the coming near future. While Polygon is the layer 1 blockchain solution over the Ethereum, that is another topic. And Litecoin is also altcoins, Chronos, and all of these are altcoins except for Bitcoin, and some are just tokens. So as you've seen Shiba Inu is also a token, and now there are many categories like the DeFi, the Metaverse, the NFTs, and many more guys. The BNB chain, the Polkadot chain, the Solana chain, and many more. So this is another topic. We must not diversify ourselves from the main purpose that we are here for. So guys, I hope now you have learned the difference between cryptocurrencies, altcoins and tokens. So now we'll be learning about what is the Bitcoin's monetary policy. So guys, I'll share you my story that when I was in my initial stages learning about blockchain, Bitcoin, more curious about learning them. So while I got to know about more about Bitcoin, I used to think that why it has value, why people are buying it at $30,000 and also on $65,000 as well, which is the highest of Bitcoins. So I used to think that why is that value? Where is the value coming from? Because here we can see that land has value because it is a physical asset. Gold has value because it is a physical asset. Bonds, papers, money also is valuable because it is a physical asset. Why is this digital currency getting value from or deriving value from? So I got to know about this Bitcoin monetary policy. Thanks to that I now have a greater aspect of how it is deriving its value, the value of Bitcoin, from where it is deriving its value, and why people are valuing it as an alternative to gold. So let me give you the first monetary policy, which is the halving. So what does the halving means? So the halving actually takes place after every 210,000 blocks, which takes about every 4 years, as one block is added to the blockchain every 10 or so minutes. So you might be thinking halving means, so the Bitcoin that are rewarded to the miners are cutted into half each 4 years. So this reduces the value. Let me tell you that here you can see the Bitcoin halving is there. And in 2009, if a miner mined a block and added it to the blockchain, he used to get a reward of 50 Bitcoins. Yes, he used to get a reward of 50 Bitcoins. While in 2012, it was reduced to 25 Bitcoins. While in 2016, it was reduced to 12.5 Bitcoins. While in 2020 it was reduced to 6.25 bitcoins, and in 2024, in the coming 2 or so years, it will be only rewarding people with 3.125 bitcoins. And it is estimated that at the year 2140 there will be no bitcoins ever mined, and people will just get, or the miners would just get, only the transaction fees that they are adding to the blocks. So this derives the value of bitcoin, and it is not easily accessible, and people are getting the supply of it very low, and people are holding it to their wallets. So the next Bitcoin's monetary policy is Bitcoin versus deflation. Let me tell you one thing, that Bitcoin has a set limit of 21 million coins over the period of, let's say, about 80 or 100 or so years. So what happens here is that if you have only 21 million coins that are being generated, so this restricts the supply and allows the inflation to be controlled. And if people started burning the bitcoins, so what happens, that there is a deflation in the market, or the supply of the bitcoin that is circulating in the market is getting lesser and lesser and lesser over the period of time. While people hold their bitcoins in their own wallet, what happens here is that the liquidity from the exchanges are getting off, and here, when the demand of bitcoins is increasing, the price also increases. So this is more of a kind of a price to ratio thing, or the price economic thing. Here we are not discussing about that, but I am giving you a brief about what is bitcoin's monetary policy here. So there is no central bank continuously distributing currency and regulating monetary policy in the case of Bitcoin. What happens here in Bitcoin is that it is settled by Satoshi Nakamoto in 2009, and everybody after 2009 has to follow it in the Bitcoin network. Moreover, no central authority, nobody owns the whole of the blockchain of the Bitcoin, and nobody is the CEO of Bitcoin, let's say, and no central bank is having the authority over the Bitcoins. And what happens here is that they cannot regulate monetary policy of the Bitcoin, as it is decentralized, distributed, and peer-to-peer, as you have learned in the case of the definition of blockchain. So what happens here is that it is settled that it will be 21 million coins, and people are now going crazy about Bitcoin, that if it is only 21 million and people in the whole world currently is around 7 billions, and if one person also holds a Bitcoin in their own wallet, what happens here is that there would be many people who don't have Bitcoin, and this is how the scarcity of Bitcoin is created through Bitcoin's monetary policy. What happens here is that in this diagram you could see here. So let me show you that this is a diagram. Year 2010 is there, and from 21 million, and this supply is going to zero, because this is the block rewards that you're getting here. Here you can see that it started from 50 and it is going to go low as 0.0061031 and so on and so forth, which is ending at zero only. And this marketing circulation of the supply is going to increase over the period of course of time, and in 2034 everybody will get the access to 21 million bitcoins. So yeah, that it derives the value from here. And you can be, so what is bitcoin used for? Bitcoin is basically now used for not as a peer-to-peer electronic cash system that Satoshi Nakamoto proposed it in its white paper, but Bitcoin is basically used for as store of value, or as an alternative to physical world gold. So understanding mining difficulty. Let's say you want to mine a block. So you need to understand what are the pros and the cons of the mining difficulties. I know that you don't want to go in the technical details, but let's just have a overview of what is this so that you could have a computation in your mind that what is this mining difficulty all about. So the current target of the blocks, let's assume is this, it is this 64-bit hash cryptography. What happens here is that the starting 18 digits of this hash is 18 zeros. So let's do a estimate of what's the probability of you mining a block. So yeah, so this is a total possible 64 hexadecimal numbers like 16 into 16 into 16. So 16 to the power of 64, which is equals to 1 in 1.157 into 10 raised to 77 or 10 to the power 77, which is definitely equal to 10 to the power 77 approximately. So here what happens, total valid hashes with 18 leading zeros. So 16 into 16 into 16, so that give us 16 to the power 64 minus 18, which is equal to 2.459 into 10 raised to the power 55, which is equals to 2 into 10 raised to the power 55. So what happened here is that, so the probability that the random picked hash is valid is around total valid hashes divided by total possible 64 hexadecimal numbers, which is equal to 2 into 10 raised to the power 55 divided by 10 raised to the power 77, which is equal to 2 into 10 raised to minus 22. I am actually laughing here that the probability that the random hash that you picked or that you mined is going to be the valid hash is around 0.000000000000000000000000002%. Yeah, guys, the zeros that I have spoken is much lesser than the that you can see in this screen. It is far, far, far harder than you think to mine a block as you compute the hash and that hash is valid that you have computed. So it is very, 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 very tedious work to mine a block, and that block that you mined is really a proof of work. Yeah, guys, I can tell you that it is really a proof of work because it is so tedious. You can just imagine that it is completely zero. It is completely zero. That 2 that at the end is just for namesake, guys. So here comes another understanding mining difficulty where you might be knowing that how it is calculated, how the mining difficulty is calculated. So difficulty is basically the current target upon the max target. So let us assume that this is the current target, this is a max target, and you need to mine the block, which is again the difficulty is going to come around 0.0000 around 18 zeros, and at the end it will be 2 or 1%, which is equal to actually a 0% chance that you will mine a block or the hash that you picked is going to be valid. So what happens here is that Satoshi knows technology is going to advance another 100 years, 200 years, and the computers that are going to be built are going to be very, 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 very fast in computation power, in graphical processing units, and ASICs, and many, many more, guys. So, what happens that he has adjusted the difficulty of mining blocks in such a way that every 2016 blocks means around in every 2 weeks that the blocks are mined in the Bitcoin, the mining difficulty is adjusted. Adjusted means it is increased to a certain rate where it could be paced. Paced means it could be in the same level of the computers that are going to mine the blocks at the same age. So what needs here? So this is what tells that you need to upgrade the computation power that you are using to mine the blocks. So let me give you an example that let's say I set up the mining rig in 2009 and I set up the mining rig of around $50,000. What happens here in 2009 and in the year 2109, I cannot use that same rig to mine blocks at that time as well because the mining difficulty would be very, very high and the BTCs or the bitcoins that I'm going to get, it would be very, very low. So people are just FOMOing. FOMOing means fear of missing out, that they do not just miss out on Bitcoin, this ever life changing chance to make money, because they are thinking that the early the better, and that's true in some cases as well, guys. So this is the mining difficulty that you need to learn, that it is adjusted every 2 weeks, and people are just burning their money and electricity and computational power to just run the network of Bitcoin. To know more about the mining difficulties, I'm going to take you to this tab of mining difficulty. So let's go. Guys, here I am, blockchain.com /charts /difficulties. So here you can see the network difficulty or the mining difficulty. So this is a network difficulty chart where it shows the difficulties to mine a new block for the blockchain. So ever you can see that it is increasing. So from July 2021, it is increased rapidly, and it is ever increasing and ever increasing. And now you can see that it is at its peak, which is 31.25 T, or total hash rate. So to know more, here we can see that miners revenue USD that they are getting in the period. So what happens here is that you can see miners were getting $20.581 million in July 2021. It reached a peak of around $18 million in October 2021, while it is now at its all-time low of 24 million dollars. And the all-time chart is ever increasing, where you can see in the starting days you were not getting any dollars because it didn't have any value. While you can see here it started from around 30 to 20k, and now is ever increasing, and it reached a height of $60 million. This also moves the price of Bitcoin at a very high rate. As you know that the difficulty is increasing every 2 weeks, and people need to mine Bitcoins to their fullest, so it cannot be done, let's say, with a normal computer, with a normal GPUs, with 10 or so GPUs. So what people have done, people have created mining pools. So what is a mining pool? Let us understand this first. So mining pool is a joint group of cryptocurrency miners who combine their computational resources over a network to strengthen the probability of finding a block or otherwise successfully mining for cryptocurrency. So what happens here is that, so people, let's say, who want to mine Bitcoin, they combine their computational resources over a network to strengthen the probability of finding a block. So let's say I want to mine a Bitcoin. So the probability that I will mine a Bitcoin would be 1 in 100. And let's say my 50 of the friends join with me. So the probability of us finding a block would be around 51%. So now we'll say that how we will distribute this reward. So let's say my computational power was around 10%. So I will get the 10% of the reward. Let's say we get 1 Bitcoin. So I will get 0.10 Bitcoin. While the other people will get the rewards as per their computational power or computational resources they use in the mining pool. So the biggest of the mining pools as per current data resources is the ant pool at 25.2%. The BTC top, it is at 11.2%. Means 11.2% of the BTC miners are BTC.top miners who have a joint group and share their computed power in them. So BTC.com 10.2%, Bixin 8.1%, BTTC pool, and F2 pool via BTC, BW.com, Bitcoin.com/pool, unknown, GB miners, Bitfury, Kano, One Hash, Telco, Backpool, Water, Hole, Connect BTC, Bitcoin India, Solo CK pool, Bitcoin Russia, and many others. So here you don't have any chance to get into BTC mining, as it is very hard to mine a Bitcoin through these pools. So you can't just fight with these pools. And through these mining pools, there is another difficulty that is created that we'll be learning later in this course. So yeah, let us now talk about the drawbacks of mining and mining pools in general. So here is a research paper of Columbia's environment school, where they have been telling us about the market capitalization of all of the 19,000 cryptocurrencies that are there in the market, which is around $2 trillion, which is immense, guys. So what happens here is that Bitcoins, the world's largest cryptocurrency, currently consumes an estimated 150 terawatts hours of electricity annually. So it is more than the country of the Argentina, which has a population of 45 million people. Yes, so you can just imagine that 150 terawatt hours and more than the country of Argentina, and it will be ever increasing in the coming near future. So what happens here, that producing that energy emits some 65 megatons of carbon dioxide into the atmosphere annually, comparable to the emissions of Greece, making a crypto a significant contributor to global air pollution and climate change. So you can just imagine that, guys, that this mining system and the mining pools, they are just destroying our mother earth. So what happens here is that 150 terawatt hours is not a small number, as it is very very big number, and it is a greater concern for people and for the Fed and all of the humans that are staying in this mother earth. What happens here is that it is annually releasing about 65 megatons of carbon dioxide, which is not a joke. It can also cause global warming and permanently change the climate of the mother earth. What happens here is that the, they have found out a new consensus mechanism. As we know earlier that it is a proof of stake, and Ethereum also has started to move in proof of stake, and is in the near coming future it is going to shift from proof of work to proof of stake, which is far better, way better than proof of work in terms of this energy consumption part. So yeah, looking forward to proof of stake blockchains that are going to be created in the coming near future. Now let us learn about nonce range. What is a nonce range? This is just for your education purpose, that you know that what is a nonce range and what are the numbers that you're going to see in the nonce range as well. So here is the block. As you know that the block number is there, the nonce is there, which is not there now because the hash is not computed yet. The data is there that is stored in this block. While Joe is transferred 100 Phyto coins to Jack, Rohan to Geeta 500 Phyto coins, Jack Amazon 50 Phyto coins, and the previous hash is there. So it is, as it is a block number 3, so the previous hash is there. If it was block number 1, there will be no previous hash. Here is the linking of this block to other blocks as well. The nonce is basically a 32 bits number, not a 64 bits but a 32 bits number. So what is the 32 bits number and what are the range of that 32 bits number? Let me tell you now. So what happens here is that the 32 bits number ranges from 0 to around 4 billion. So the nonce can be any number from 0 to 4 billion. So you can just get assured that it is from 0 to 4 billion, while it is not a small number, but yeah, it is not that big as well, and it can be achieved through greater computational power. So how do miners pick transaction? This is a very 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 interesting topic where you might know that how do miners pick transaction after they validate a block through the process of mining, which we know that the process of mining is very hard. So they need to also earn some of the tokens. So this is the mempool. Mempool is basically a memory pool that is created. See, a block is going to be mined after every 10 minutes. What happens here is that you are going to do transactions every second also. So what happens, the transaction are stored temporarily in this mempool. So after mining in process, once the miner mines that block, what happens here is that he needs to take transactions from this mempools and store it in the block so that it is confirmed and it is forever in that blockchain. So how will the miner pick the transaction? So let me give you a basic example. That miner will first choose the transaction that is giving him a high transaction fees. Let's say here he is getting a fees of 0.00850 BTC, which is higher than all of the fees that are there in the mempools. So he will first pick that transaction. The second transaction he will pick is relatively smaller than that transaction, and then going in the descending order, he will pick the transactions, and how much transactions the block can store, he will pick transaction as per that data. So what happens here is that you need to give a higher transaction fees to the miners so that your transaction is added to the block very soon. What happens here, that if you do a lower transaction fees transaction where you are giving very low transaction fees to the miner, so he will not put your data in the block, and what happens at the end is that your transaction ends up being cancelled. So please do understand that they also mine the block very hardly, and they also have their computational power which is very high, and the cost of the energy is also high, so you need to provide with the transaction fees that they can earn as well as an extra income apart from the bitcoins they are getting, which is newly generated or minted when they mine a block. So to mine a block, what are the different parts or components that you are going to need? So CPU, central processing unit, it is there in every computer. CPU is the basic brain of your computer. So it is a general because it every computer has a CPU, and it is less than 10 megahertz, so it can produce the hash in less than 10 megahertz, which is very slow and low power, because if you can produce a hash in 1 terahertz as well, it is very low. So this is so slow and so low, it cannot be used to mine bitcoins as far as now's technology is concerned and computational power is concerned. So GPUs, graphical processing units, these are specialized. These are specialized for gamings, for uh, all of this graphic intensive works. So this graphical processor unit, it produces less than 1 gigahertz of the hash rate, which is very good than the CPU, but not as good as it is needed. So what happens here is, yes, you can align graphical processing units like 10 to 15 to 20 units, and you can lay them off and use them very often to mine bitcoins and all of the other cryptocurrencies that uses proof of work, so that you could achieve a more chance to mine a block. And the last but not the least is the ASIC. ASIC is the application specific integrated circuit. It is very specialized for mining bitcoins, and it produces more than 1 gigahertz, which is the very best till now. As you can see that you can produce more than 1 gigahertz from ASICs, which is very good. So CPU versus GPU versus ASICs. So CPU, you can see that Intel Core i7, Intel Core i3, i5. These are all the CPUs, and AMD Ryzen 3, 5, 7. These are all the CPUs that you see. Generally, this is a GPU, graphical processing units. These are not there in a laptop because, as you can see, the size of this is so big. It's thicker than the laptop nowadays. So what happens here is that this is used in basically the desktops and mining rigs. This is a ASIC. So this is a simple design that the ASIC can be used. So what happens here is that they build a logic cell, and on that logic cell they build an integrated chip where the circuit is designed and it is used for the ASIC to produce this high computation power. Let me start with a new block that is known as the orphan blocks. So what are orphan blocks? Let me explain you with the help of a diagram. So orphan blocks are valid blocks which are not part of the main chain. They can occur naturally when two miners produce block at similar times, or they can be caused by an attacker with enough hashing power attempting to reverse transactions. What happens here is that orphan blocks are the blocks that are not part of the main chain. So let me give you an example here with my pen. So here is the pen. Here you can see that the block number 503948 has computed two blocks. So this is a one block and this is another block. So one block is relayed by GB miners, you can see here. The other block is relayed by slush pool. What is happening here is that the timestamp, you can see it is more or less exactly the same timestamp, and these two blocks are valid blocks. But what happens here is that they are separated now, and the chain is formed only of that block that has been mined before. Let's say here the timestamp says 232807, and here the timestamp says 232833. So obviously the GB miners that mine that block would be considered as a correct block because it is mined previously, and also the number of transaction in this block is 2991, and the chain continues from here. And what this block is being doing means the slush pool block, this is not considered as a valid chain, and after 2 to 3 blocks that are going to be mined after this block are going to be discarded from the blockchain, and the transactions that were stored in this block would be reversed to the mempools. So you need to double cross check of these types of transaction, as it can happen with you as well when you're trying to transfer bitcoins to anyone in this whole world. So you need to double cross check. So that is why it is a rule that you have to check 60 minutes after a transaction that your transaction is confirmed, and after 5 to 6 blocks are added after your transaction, you can be sure that your transaction is now confirmed and the other counterparty is paid. That is the concept of orphan blocks. So now let us come to the 51% attack. So this I was going to talk to you about in the mining pools only, but I thought that no, we must make a next section for it. It is because it is very big and you need to learn about it. What is the 51% attack? So 51% attack happens when a malicious user in a network acquires controls of the given blockchain's mining capabilities. It implies that the attackers will have more than 50% of the mining power and can mine faster than everyone else. So what is the 51% attack? Let me explain you with the help of a diagram. So let's say this is the valid chain here that is been mined by miners who are true to the network. So what happens here is that, let's say this blockchain is very low blockchain, only 3 to 4 people are mining these blocks for out of the blockchain. What happens here is that at this block, this particular block, attacker comes here and starts mining another blocks from this block, and it has the same computational power as far thus these three all are having. So what happens here is that as they are same, so the attacker can reverse the transaction, the attacker can stop the transaction, the attacker has all of the controls to this blockchain. So what happens here is that the majority of the miners are added and broadcasting block to the public blockchain, but an attacker is adding blocks to a private blockchain and not broadcasting them to the public blockchain. But after that it is broadcasted to the public blockchain, the transactions are going to be reversed and all of the steps are going to be happen. Let us see what are the side effects of the 51% attack. So here you can see that the impacts of the 51% attacks of the blockchain are basically new transactions are delayed. So in a 51% attack, the attack invaded the hashing power of the Bitcoin, so they can delay the new transaction, initiate the use of several coins at the same times, so causes network disruption. So what happens here, if 51% of the mining power is with one entity or a group of people, they can control the computational power and the resources of the network and can disrupt the network, destroy the network, or use it for their own fun as well. So if the 51% attack happens on the blockchain, so the people who are miners, who are genuine miners, they will get less rewards, mining rewards, as they would get from normal blocks because of the double spending attack of the coin. So these are the impacts of the 51% attack on blockchain. There were many 51% attacks on the blockchain which you might be knowing or you might not be knowing, but there were many. So there was attack on Bitcoin as well, when Bitcoin was very relatively very low and it uses very low computational power, so people used to match that computational power and congest the network and use it for their own means. That's how many of the bitcoins has been lost by the people. So at the end guys, thank you for watching this video. I hope you've learned about cryptocurrencies, and we are going to move to the next section of this module. So yeah, let's wait for that video. So as you've learned about what is a cryptocurrency and basic fundamentals of cryptocurrency, now we are going to see and deep dive more into what is transactions and UTXOs. So transactions and UTXOs are completely different from each other. Well you might not be knowing that, but basically transactions are different from UTXOs. In the normal general world where we use banks and all of these business related processes, transaction is basically a process where money is handed over from party A to party B, and that is only a zero sum game transactions. While in UTXOs are basically unspent transactions in Bitcoin world. So let me explain you all of this in a more detailed and explanatory way where you could understand better how your wallets are working, how your transactions are working, how your transactions are being stored in the blockchain. So let's get started in this video. So as here you can see the transactions and UTXOs. Here let's say that Joe transferred me 0.1 Bitcoin and Sam transferred me 0.3 Bitcoins. Katie transferred me 0.6 Bitcoins while Susan transferred me 0.7 Bitcoins. What's happening here is that these Bitcoins are stored in my wallet and these are my unspent transactions. Basically, that I have not spent all of these Bitcoins, let's say 0.17 Bitcoins from my wallet to buy or spend on anything. So what happens now that I want to buy a bicycle for 0.5 Bitcoins? What happens here is that I have to send a transaction. So input, I will send 0.6 Bitcoin from Kitty. So what happens in the output is that 0.5 Bitcoins goes to the bike shops that I am going to buy a bicycle from, and 0.1 Bitcoin goes to myself as a UTXOs because unspent transaction for me now, while the 0.5 Bitcoin that I have transferred to the bike shop is the UTXO for him, means unspent transactions. So in Bitcoin world, the transactions that are stored in this to anybody in peer-to-peer networks. So the next is that let's say I want to buy a second bicycle for 1.1 BTC and I have the same Joe sent me 0.1, Sam sent me 0.3, Katie sent me 0.1 and I have my 0.1 Bitcoin from the previous transaction as well. These are all my UTXOs. I want to buy a second bicycle for 1.1 Bitcoin. The input here is that I will take 0.3 Bitcoins from Sam, 0.7 Bitcoins from Katie, and 0.1 Bitcoin from myself. While adding all these things up, I will give 1.1 Bitcoin to the bike shop, and that 1.1 Bitcoin would be an UTXO for that bike shop as he might have not spent those tokens till now. So where do transactions fees come from? You might be thinking that, oh, how are people or how are miners getting transaction fees? So let's just deep dive into this and let's just see what is happening behind the scenes here. So where do transactions come from? Let's say we'll take an example here. Joe sent me 0.1 BTC, Sam sent me 0.1 BTC, Katie sent me 0.4 BTC, eBay sent me 0.3 BTC, Susan sent me 0.3 BTC. Now I want to buy a third cycle for 0.9 BTC and an Apple for 0.02 BTC. What happens during the transaction is that I'll take an input from KT as 0.4, from eBay as 0.3, and from Susan as 0.3. What my output would be for is that 0.9 Bitcoin as I wanted to buy a bike or a bicycle. So I'll give to that person, I'll transfer it to them, and 0.02 Bitcoin I'll transfer it to the fruit shop for buying the apple, while 0.06 Bitcoins would be reverted back into my account as an UTXO, means an unspent transaction that I have not spent till now. And those two transactions that I've sent, that let's say 0.9 Bitcoin would be for the bike shop, while the 0.02 Bitcoin for the fruit shop would be an UTXO. So from here only the fees come from, that when I'm sending transactions, the network is asking for fees from me upon the amount of the transaction. So let us now get more curious and see how wallets work, because everything in this world is in the form of transactions. And while we have seen just unspent transactions, here you can see these are blocks. Let's say 502, 503 and 504. What happens here is that in these blocks, these kinds of things are being stored. It is not like that you have a balance of, let's say, 1 Bitcoin, 10 Bitcoins and all those these. It this this blockchain is just storing data. It's not using data for us in a more useful way like the centralized exchanges use. So what happens here is that I have transferred to my shop and I have transferred to myself as a UTXO. Joe transferred to me 0.1, Sam transferred to me 0.4, eBay transferred to me 0.3. And from me I'll give it to the bike shop, to the fruit shop, and to me as well 0.06 BTC. What happens here is that I will just add all of these and my balance would be 0.96 BTC. But you will ask me that how it is possible as everything as it is shown in transactions. So what Bitcoin wallet does where you are going to store your Bitcoins forever and ever, just hodl it guys. So what it will do is that it will just keep a record of it, and the unsigned transactions that you have, it will just add them up and display on your screen in front of balance tab. Let's say I have how many unspent transaction I have. Let's say 0.06 is there, 0.1 is there, 0.4 is there, 0.3 is there, and 0.1 is there. So what it will do, it will add all of these for me, and at the end it will display as a balance a year in my wallet tab. So this is how wallets work in Bitcoin and in Ethereum as well as Litecoin and ICP and many other blockchains that are coming today and coming near future. So yeah, that's how basically a wallet works. So what is segregated witness or SegWit? Let us look at it. So segregated witness, here you can see that here is a block that's showing basic details. Let me highlight this. Let's say it's showing it is showing me block which is of 500,000 timestamp. This timestamp don't get tensed. What is it? And don't get worried. It is basically a computer science way where we show real world time into a more integer kind of a way where you can just display it, and if you copy this and paste it in Google and you will see the exact timing of what is the time now. Here is the nonce that was computed. Here is the transactions list of what are the transactions that are stored. You can't read all of the transactions because it is a more hash cryptographic way. While here you can see that is the previous hash is here and the hash that is computed is here. This is the basic building block of a block, and all of these are stored in 1 MB of data. Yes guys, here you can see it is stored in only 1 MB of data. This is the hash. So here you can see this is the hash, while from X and to Y, the amount would be 0.3 BTC. So what happens here is that here is the signature and here is the public key. So signature means that you don't have to sign it with a pen or wet sign. You just have to sign the message on the wallet that you are being using to transfer, and that is how segregated witness happens, guys. So here is an additional reading where you can just understand SegWit block size, and through this you can learn more about SegWit in a more deeper way. So yeah, that's what you can do. So public key versus Bitcoin address. What is this? So what happens here is that there is a private key that you need to store to have the access of your wallet, while there is a public key which you can share with everybody, and they can send money to your public key address. So what happens here is that let me give you an example. Private key is basically the password that you are storing for yourself and not giving to anyone, while the user address or the Gmail address that you are sending to another person to send you some mail or stuffs, that is the public key here. So what you can do with private key is that you can read a message to that private key and you can sign the message to the private key as well. And through public key, you have a verification function that okay, that person has this public key and it is now useful to me. And you can also sign a yes and a no through your public key as well. Public key versus Bitcoin address. What is this? So let's say two people are there, Kirill and Hadlan. What happens here is that in this part, like in the lock part, there is a private key. So the private key is linked with that public key, and the public key is linked with the address of the Bitcoin's one. Here you can see that private key has the access to the message part and the signature part, and message will verify the function that okay, this is sent to me from other person only, and that is the function of this public key, and it will say yes or no. If it is yes, then all the messages will be transferred and will be signed duly, while if it is no, nothing will happen and the transaction would be reversed. What happens here is that Heartland, he has the same function, but the message is being passed from the Kirill's public address or the Bitcoin address to the Heartland message tab, and from there the message tab will just recognize okay, that this is the person who has sent me a message, let me see what's inside it, and he will sign the contract or he will sign the transaction while clicking yes, and now he can read the data in that message. So here is an additional reading where you can see what is the difference between the public key and the public address. Now we have come to the hierarchically deterministic HD wallets. What are these? Let us now understand all of this in a more detailed way. So hierarchically deterministic HD wallets are basically, I've shown you before also, the private key is there in the lock section, while the private key is linked to the public key and the public key is linked to the address. While this is not a same case in the Ethereum part, Ethereum, the private key is linked to the public key address where you don't need another address, or your public key will only do the same for as the public key and address both combined in the Ethereum one. If you have installed MetaMask before, you will know what I am speaking. So what happens here is that the private key, what happens here is that let's say someone sent me a message and the public key will verify the function of that message. Okay, it is sent from someone who I know. It will pass yes. Then what will happen after yes is that the message would be signed. The message would be signed and I can read the message afterwards. And what happens here in the HD wallet is that the private key is linked to the public key and the public key is linked to the address. And here you can see many private keys are linked and many public keys are linked to the address. Now LT wallets are being lately very tedious to manage, as you have to know so many keys. First the private key, second the public key, then third is the address. See, you have to learn so many things, and if you have two to three to more accounts, then all of this tedious work will just multiply for you. So what they have taught, the HD wallet maker, they have taught from master private key. So what this master private key will do, if you have this master private key, you can access all of your accounts. And let's say if someone wants to send you uh, transactions from your public key, what they can do, they can just take your public key and they can send transactions to it, and this public key will just verify the function for all of the private keys and all of the public keys, so that you can easily transact or send a message to them. So here you can see this is a master private key, and here is some of the photos which is very good, and you can see that which collapse, practice, feed, share, open, despair, creek, rod again, eyes, lead. So here is an industrial reading about the deterministic wallets, their advantages and their understated flaws by Whitelake Buterin 2013. So here you can see that the Bitcoin by Whitelake Buterin has uh, published a blog on the Bitcoin magazine in 2013. So yeah, you can see and read all. So guys, at the end, thank you for watching this video and hope you have learned something about the transactions, the wallet, the secret witness, and all of these complex things, and hope that I've explained you it in an easier way and easy to understandable way. So hey guys, as promised, we are going to build our own small blockchain where we'll see the properties of a blockchain, how is it working, and all the contents of a block and everything that we have learned till now about blockchains. So yeah, let's get started. So here I am at an empty directory. So my blockchain name is fighter coin. So what I'll do, I'll just open it in with VS Code. So I'm right clicking on it and opening it with VS Code. Now you can see my VS Code is opened here. So what I just need to do is click on a new file, type in main.js, as this is a JavaScript file and we are building our blockchain on JavaScript. So what I first need to do is I need to define a class block. So class block. So here I am. So guys, here I've created a class block and open parenthesis, close parenthesis. Now what I'll do is here I'll pass in a constructor. So you can see a constructor. In that constructor, I need to define all the contents of my block, like the index that I've shown you, at what index my block is, the timestamp, means at what timestamp the block was mined, the data, the previous hash, which I will set it as null for now, because you know the Genesis block previous hash is always null. So now what happens here is that I have passed in this constructor wherein takes argument as an index, the timestamp, the data, and the previous hash, which is set it to null. So what I need to do here first is that to allocate them the memories. So this dot index equals index, the this dot timestamp equals timestamp, this dot data equals data. Next one is this dot previous hash equals previous hash. And now I'm adding one more component here, is that this dot hash, which I'll be setting null here for now. I need to calculate this hash, so I'm making a new module here naming calculate hash, wherein we'll calculate the hash of the given blocks. So what this calculate hash function will do, this function will take in the constructor means contents of the block, like the index, the timestamp, the data, the previous hash, and compute the hash on top of these things, and then give us the hash through that algorithm which we've talked earlier. So to make this calculate hash, we need to first install some dependencies. So in terminal, like you can see that there is a fighter coin directory. So in that directory, what we'll do npm install dash dash save crypto.js. So here you can see that it has been installed on my directory of the fighter coin directory. So let us wait till it gets installed. Now I need to import this file in my code. So how can I do this? I can just type here constant SHA-256. As you know that we are going to use SHA-256 hashing algorithm. If you have not seen the previous module, go just check it out and you'll know what is SHA-256 hashing algorithm and why we are using it in our this little blockchain. So require statement, wherein we'll require crypto dash js forward slash SHA-256 and a semicolon. So now imported in our code. So let us now close this terminal. We don't need it anymore right now. So what we'll do, we'll first do the calculate hash function. We'll write this calculate hash function, and then we'll create the class blockchain. So now it is returns SHA-256, wherein we have to type all of these dependencies in this return SHA-256 hash. So this dot index plus the, this dot timestamp plus this dot previous hash, and we are just going to stringify our data function so it is more user friendly when we look at it, and we can see it in a simpler way. Let me tell you that. So now what I'll put here is this dot data. Okay, no database, it's data. So what happens here is that we have done all of these things, but we want to output it as a string. So here I'll write a function to string and this. So yeah, now let me show you this. Yeah, that I've written here to string, but I'm missing something here, is that is the semicolon. So guys, I have zoomed out my screen so that you can easily see and read all of my code. So yeah, now let us create our class blockchain. Block and chain. So what we'll do here is we'll pass a constructor in this block, constructor, an empty constructor which doesn't needs anything, but in that constructor we'll pass that this dot chain will initialize our chain in this constructor. So empty for now, as we have not done anything yet. So what we need to do, we need to first create our genesis block. So we'll create our genesis block as a function. So create genesis block. So create genesis block. Now what we'll do here is inside the genesis block we'll return new block. As you've seen this class block, we are taking that parameter, that as a parameter, and now what we'll pass here, we'll pass the index first as you have seen it, then the timestamp I'm adding here as a string. So the timestamp, let me put a random date, that is 1st May 2022. And now what I have to do is here name it a genesis block where this is a data here, and after that let me put the previous hash as 0. So now here you can see that I've created my first block, genesis block, on my own, and I've passed in data here. So we need to add some more functions here so that we can be updated from this blockchain. So first, before adding the functions, let me add here that it is this dot create genesis block function. So yeah, we've completed this constructor part and the create genesis block part. So now what we have to do, we have to create two more functions, that get latest block. So this is a function or a module as in JavaScript we say, and the next function would be add block function. So add block, as we need to add block in our blockchain. So add block would be basically new block. So yeah, here it is, you can see that it's new block, and these are the two functions that we have created. So here, as we have created new functions, so let us pass in the criterias for this function. So return, so to get this latest block we need to return the length of the chain. So let me first put it that return this dot chain, so this dot chain dot length minus 1. Because of the indexation of the blocks, it starts from 0. So when we need to get the blocks, we need to put a minus 1 here, as you might be knowing if you are familiar with JavaScript, and if you are not, so now you know. So add block functions, so the add block functions, it needs some more lines of code. So let us start with that. So new block dot previous hash, because as we need to compute its previous hash as well, we need to get that previous hash, equals this dot get latest block dot hash. So this is the way that we are going to get the previous hash of a block here in the new block function. So we have that data as well in our new block, and new block dot, dot hash. So here we are going to leverage this calculate hash functions. So let us leverage that function here now. So new block dot here I have down that calculate hash function. So let me pass it as a function, and we have leveraged it successfully. So after calculating the previous hash, the hash, and linking them, now we will need to push this in this chain. So this dot chain dot push. So here we'll pass new block. So successfully we have created this small little cute little blockchain. So here they are showing me 6 vulnerabilities. I don't know why. Okay, so here it can't be like this. Great. So as you've seen, I've made a silly mistake that in class something different. So yeah, you should take care of this. And now also I'm making my fingers crossed, as you never know what is going to happen with this coding part. So okay, now let me not waste any more time of yours, and let me just start with that initialization of my block. So let what I've named it, it's fighter coin. Let fighter coin equals new blockchain. So I've initialized my blockchain here. So now let me add some blocks. So fighter coin dot add block. So now you have seen, now you know that add block function that we have created here. So we are going to leverage that function with the new block, and now I'm going to pass in all of the data that's required. So first we need to pass in the index will be 1 as usual. So before you have created the genesis block, there I've passed in 0. Here I'm going to pass 1. So the next date I'll put as 0205 2020 2022. So as you've seen here, this is the block that's created the next day or mined the next day. I just need to put the data that I want to put in the block. So I'll put an transaction, as it is a blockchain, and I need to store all of my data here as a transaction history. So the amount that I'm going to put, let's say that I transferred around 100 fighter coins to my friend, and I'll put a semicolon here so that I don't get any coding mistakes. So what I need to do here, I'll just copy it and create another block here. So let me create another block here and just paste it, and I just need to change all of these datas now and nothing to change more, as it is easier. So 03, and the amount that I'm transferring, let's say now I'm transferring 50 coins to my other friends. So what we need to do here is that we need to console log, and we need the data in the JSON file. So I'll put JSON dot stringify, and I'll write the name, fighter coin name here, and then next I'll write pass in null function, pass in as the null, and pass 4 here. And after that I need to put a semicolon here, save this file, go to the terminal. So here, from here you can go to the terminal. So after my terminal is open, now I need to run this file. So node main.js. So let me cross my fingers and press an enter here. So let me see that if it is working or not. Oh, I got some error. So what's that error? Let me just check it. So guys, I have realized my mistake here. Sorry for the interruption. Coding is this thing that was scratching your head. So yeah, I'm just scratching my head. I just scratched my head. I forgot that I have to pass in here the calculate hash function. So yeah, I am just passing it now. So this is very shameful, but yeah, this is what this is. So I've passed it. So let me cross my fingers once again. Let me clear the tab. Let me run this file node main.js. Now also that it's not here, figure out my error. So the file I've downloaded was crypto.js, but to my surprise, it should be crypto-js. So dash dot I got confused. So sorry for the problem, guys. So let me now install it again. So npm install dash dash save crypto-js. So here you can see I've installed the correct file now, and I will run it, and let us wait for it to install. Then after that we'll rerun our file and check that if it is installed correctly. So here you can see that it's installed now. So let me clear it first, clear, and let me in the file again. So node main.js. After many tries, now I've gotten my cute little blockchain here. Is as you can see that this is the chain in my blockchain, and here is the index 0. This is my genesis block. Here is the hash that is computed by the SHA-256 hash. Here is the index 1, while here is the amount of the data that I've transferred 100, and here you can see the previous hash in the block 1 is linked to the previous hash of the block 0. Here you can see that the previous hash of the block 2 is linked with the hash of the block 1. So here you can see that my blockchain is being formed, and all of the amounts that is there is being created and stored correctly, guys. So now I can feel assured that my cute little blockchain is just working fine. And so let me now close this terminal, and let me now propose a new function here in this cute little blockchain, that is chain valid. So because I need to be sure that my chain is valid every time I produce a new block, or to maintain the integrity of that blockchain. So yeah, let us now build a function is chain valid. So what this function will do, let me explain you, that it will loop over every block and see that all the hashes are correct and all the hashes are linked together. So yeah, let us now start with it. So for let I equals 1, I equals 1 because I don't want that I should be 0, because 0 is a genesis block and I have only created that genesis block, so there is no need to waste my time on. So this dot chain dot length, I need to make it loop over the last block, and now I need to increment it. So I plus plus, as you might know that how is a for loop works in these JavaScripts and object oriented programming languages. I need to define some variables here. Some variables are that this current block equals this dot chain the block at index 1 or index I. So yeah, this is my current block, and the next is constant previous block. Means what is the previous block that we are talking, previous block that we are talking about. So this dot chain, so here I minus 1, I minus 1 means the previous block at the ith term. So what I need to do here, I need to add some conditions here, that if if my current block dot hash is not equals to, means its bang equals to current block dot calculate hash function here. So what I need to do, I need to just return false here, that no, this chain is not correct, and we need to take a look at it. And now here, that if next function is if current block bang equals means not equals, you might be knowing that bang equals means not equals in programming language. We don't say exclamation equals. So is not equals the previous, means it is not linking towards my previous block hash. So in that case also I need to provide return false. So return false here. So now if it passes to the loop, it passes through the loop, so it is my duty that I need to return true. So here I return true as well. So here you can see that my function is ready. I think so that, so I need to save the file. I would need to pass another console.log that gives me the state of my cute little blockchain here, that is that chain valid or not. So let me verify it, that is it valid. So I'll write here that is blockchain valid, and put in a question mark here. Plus fighter coin dot my function name is chain valid here. So here I need to put an semicolon, and now I'm good to go with this. And I've passed in this function here, and console.log is also ready. So let me now go to my terminal and just node main.js, and now let me run this file, and it is saying false. So now as you have seen that I've created my cute little blockchain here. So now the last thing that is remaining here is that I need to add a SHA-256 hash. So let me add my SHA-256 hash now. So now guys, let me add a function that will mine our blocks. So let me name that function mine block. So what we'll be doing here is that we'll import SHA-256 hash, and we'll compute that hash here, that will be known as the mine block, and we'll pass in here as a argument called difficulty. So we'll pass in the difficulty, as I've shown you what is a difficulty in this case is here. See why we need mine block, guys. We need mine block that we don't want our blockchain to be tampered. Let's say anybody can uh, add a block within seconds, guys. So it is very harmful. Let's say they want to destroy my blockchain, so what they will do, they will start on adding blocks, and after a time my blockchain will get devastated, and it will get tampered, and it will just congest the network. So imagine that you are adding hundreds of thousands of blocks in a second and a minute, so that will just destroy it. And in the case of Bitcoin, you add a block every 10 minutes, so that's why the network of the Bitcoin is safe till now. So to ensure that our little blockchain is also safe, so what I will do here is I will put a while loop here. So guys, in this condition of the while loop, I need to take a substring. So this dot hash dot substring. So what stuff this substring will do to me, it will take two arguments, so 0 till difficulty. So it will start over from 0 and the difficulty that I pass to it, and this also if it is not equal or bang equals to, let me create an array of the blocks or array of the difficulties of the blocks. So array difficulty, and I need to add it by 1 every time. let me join it with 0 here, and let me calculate its hash as well after passing this condition here. So this dot hash equals this dot calculate hash function here. So yeah, my while loop is now done. After the while loop is there, now what I need to do is I need to put a console log here, console.log, wherein I need to pass a statement block mind plus this dot hash. So here you can see I've passed in this in the console log. So now guys, let me explain what is happening here. So in the mine block function, I am mining a block with that difficulties part that I've shown you here, that this dot hash, this dot calculate hash, and we are putting a console log, but something needs to be changed every time this difficulty is being increased or this while loop is being running. So can I do this with the this dot index one? No, index cannot be changed. Timestamp also cannot be changed. Data so cannot also be changed, because if the transaction is there, so if the data is changed, it will get tampered. Previous hash and hash also cannot be changed. So what I need to do here is now that I need to pass in nonce, this dot nonce here, wherein this dot nonce I will pass it as 0, initialize it as 0, and what I need to do here, I need to add it here in this calculate hash function as well, because this is not considering this dot nonce here. So I've added this dot nonce. I need to increment this dot nonce as well, so plus plus, and now it is incremented every time this function has been running till the difficulty is been reached and we get our nonce. Now what my block is doing here, it is just taking the previous hash of the block, it is just computing a new hash of the block and just putting it in the chain. So I don't want this, I want my add block function to mine that block for me now, so that it is very much secure. So new block dot mine block, this is the function here. So now let me pass it, and I need to pass here the difficulty. So to make it simpler and to make the code very good, what I need to do here is that this dot difficulty, I'll set it as, now for now I will set it as 2. So I will now set this dot difficulty as 2 and pass in here the difficulty variable, this dot difficulty variable. So this dot difficulty, I'll pass it here. So now guys, the end time has come where I just need to eliminate all of these things here, and just these 3 lines of code will be there here. So what I need to add here is that console.log and mining block 1. So this is a block 1. As you know, I can design it more better way. This blockchain is just for demonstration purpose, so let it be like this only, where we are going to just mine 2 blocks. So mining block, and which is 2 dot 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 dot. So yeah, now you can see that it is now done. So let me go over through my code. This is a good habit that you go over through your code once again. There's a change I've made, or you can see that is anything incorrect, or you have done some mistake here. So seems correct. So what I'll do here now is I'll open up my terminal, go to the new terminal and put it down here because it's too big. So let me delete previous one till then. So here you can see that my new terminal is opened. I need to just do node main dot js. Oh, let me cross my fingers and hit enter here. Mining block 1, and now you can see guys that this is something cool, very cool. Now you can see my mining of the block starts from 0 0 2 zeros, as I've passed in here the difficulty of 2 zeros. As you can see here, I'll show you that the the difficulty here in the constructor is 2. So to make it even more harder, let me make it 4 now. Let me save this file here. Let me rerun the file, means node main.js. So let me rerun it, and now you can see it is taking more time than it was taking previously, and now you can see that it is mining with 4 zeros ahead. So if I want to increase the difficulty one more time, so what I can do here is I will write here 5. It will rather take more time now as my computer is a little slow, but never mind, we'll wait until then we can have some chat as well. So node main.js. So let it take its own time and let it mine 5 zeros. Okay, it is taking more than usual. I need to wait more. So yeah, now one block is mined with 5 zeros. So that is a hell lot of a time. I can't wait that much. So now you got the understanding of basic how mining works and how that zeros are added. And to get the blockchain more safer, we have added this function, because nobody could just mine many blocks at once and they could just disrupt this blockchain network. That would be harmful for us and for this cute little blockchain. So what we have put it here, we have put it this mining function. So first let me make this difficulty to 2, as I don't want this much difficult, because it is not safe for me now, as my computer could crash as well. So now you can see that we have seen this 2 1 and the difficulty 4 1 and the difficulty 5 also. So now you can understand how this blockchain is implemented, how this blockchain is worked. If you want the code, I'll give you the code in the form of a notepad or so. So yeah, now we have built our own blockchain in the JavaScript, and this is a small blockchain. It just shows you the demonstration of a blockchain, how you can code it, how you can simplify it. Here you can see there are two classes, class block and class blockchain. So here what we have done, we have initialized a new blockchain and we have created two blocks here. And previously you have seen that our two blocks contain datas as well. So in that you can put any data, you can put any sort of data, like you could put some text also. Let's say that I am teaching blockchain technology, that I can put here as well, as you might remember. So yeah, this is our blockchain that we have made it in main.js. Here this completes our module of making our blockchain. So hope that you have learned how to make your own blockchain. So guys, after creating our own blockchain, let us now transform this blockchain into a simple cryptocurrency. As you might be knowing that we are also going to create our cryptocurrency. So what I'll first do here is I'll get rid of this code here, console.log code, and just leave it into the initialize stage. So let me initialize my new blockchain. But what I need to do here is that this data field, I need to convert this data field into transaction, as to convert your blockchain into a cryptocurrency, you need to convert them into transactions. And so I need to change here this field as well, transactions, and here as well transactions. So I have converted this part, but what I need to get rid of now is that this index part. So we don't need the index part in a real world blockchain. This index was just to show you guys how these things work. Need to get this off red, and now I'll delete this as well. So what, after writing this timestamp and transactions part, so we need to create a new class here. So class transactions. So we need to define how the transactions will look like here, what the transaction will contain. So the will initialize the transaction to constructor. So constructor, and I'll pass in. See, there are three arguments that the transactions would take or happen. So from, it will be a from address, to address, and the amount. So this is basically very simple. In real world transaction also, what we do, a person who is sending, so that's the from address, to whom he is sending, that's the to address, and to the amount that he is sending. Let me just initialize them and pass in the value for them. So this dot from address equals from address, and let me put a semicolon here, and the next one is this dot to address equals to address, and let me put a semicolon here, and the last but not the least is this dot amount equals amount. So here we have successfully created all of this and initialized them in our cute little transactions class. So what we need to do here is that previously we have added an add block function here in this blockchain, and so we need to get rid of this and we'll create a new function here so that we could add a block in a more practical way like of a blockchain. And I've forgotten this one as well, so I need to clear this index tab from here in a create genesis block, so I don't need it anymore, and I'll get rid of this add block function now. So as you are familiar that our Bitcoin blockchain, it mines a block at an interval of 10 minutes. So what we need to do here is that the transactions are happening at every second and every minute, and the block is mined after 10 minutes. So the pending transaction needs to be stored somewhere. So we'll create that variable as well, that will store our pending transactions in this dot pending transactions, pending pending transactions, and I'll initialize this list as empty so that we can store in the pending transactions. Then next we'll do mining rewards, so we need to give mining rewards to our miners so that we could distribute our coins, fighter coins, to everybody who mines the block so that they could get rewarded. So for simplicity, I'll put here 100 coins. So now let me replace that add block function here and let me name it the mine pending transaction. So here it is a new function that I've created. So guys, this mine pending transaction will receive an argument of mining reward address. So what is this? This is the address of the person who mines the block, or the computer who mines the block, so that he or she can receive the fighter coins, 100 fighter coins as a reward. And now what we need to do here is that we'll initialize our block. So let block equals block, the class block that we have created, and we need to pass in some arguments. Let's say the timestamp, so date dot now. So this is the timestamp that we need to pass in here, and comma. So and the next thing is that the and after this date dot now, after this date dot now parameter, let me just add another thing, that is a pending transactions. So this dot pending transactions that we are going to leverage from above, that we have created a function there. And now let's just mine our block. So block dot mine block, that the function we've created, and the difficulty of this mine block would be this dot difficulty. So this is leveraged from above here, that you can see we have created this dot difficulty in the constructor, so that we are going to leverage it here so that we could use it easily. So after this event happens, let me console.log. So I'll console.log my favorite words. Let's say block successfully mind. So yeah, as here, as you can see that I've created a console.log as well. So let me now append this or push this into my blockchain. So this dot chain dot push. Actually, append is the word that we use in Python, but in JavaScript we don't use that. We use push. So that's why I'm getting reminded of that append one, because I use Python more than Java. So after we have added a block to the blockchain, what we need to do that we need to empty this list of the transactions part again, so that there is no other transactions contained in it. So I'll write this dot pending transactions, which I need to empty. So equals, it's empty now. But what I can do here is that I have to add and mining reward to my miner. So let me do that as well. So I'll create a new transaction, and I'll pass that arguments to the first one is null. So there is no. Why is the from address null here, guys? Because there is no one who is sending the transactions to the miner. It's from the algorithm, it's from the system inside that it's giving the miner a reward. So it's actually a reward, and then I will write mining reward address. So it's the address of the miner and the coins. So I'll write here that this dot mining reward. So I'll not hard code here 100. I'll write this dot mining reward. So whenever I need to change the mining reward, I can change here 100. So yeah, that's all for now. But you can tell that this can be easily changed. Means anybody can change your 100,000, 10,000 lakh, even 10 lakh. In this cute little cryptocurrency that we are creating, anybody can change it. But in the real world blockchain, the system is decentralized, and if you try to change the code, what will happen there? Other people will just ignore you and will append the list over you, and your tampering the code will not work even for you as well and not for others as well. So you just can't change it because the system is decentralized peer to peer. And now you must be understanding it clearly that why we use the decentralized and peer to peer networks in our blockchain. So after this mine pending transactions, let me create a new function that will start with the create transaction. So let me just create a transaction. In that, the argument would be transaction. So here I've created a transaction. So now let me just put in the required code, the pending transactions part here. This was pending transactions dot push and the transaction. So what happens here is that this function will ask you for the transaction that you want to push it into a pending transactions list, so that it could be added into the block. So here I've created a function for it, which will easy our time and labor, so that we could easily append those to actually push those to our pending transactions. So guys, after we have completed this create transaction part, now what we'll do is we'll get the balances of the address that is passed to check the balances of our wallet address. So that, guys, you know that in a blockchain like the Bitcoin blockchain wallets, you don't actually have a balance. What happens here is that their transactions that are stored in blockchain are in the form of a transaction, and it loops over every transaction to see how many you have sent, how much bitcoins you have received, and it does a plus minus math, and then it shows you the balance. So there is no balance in the wallet, but we need to get a balance to show our user that yeah, you have so many fighter coins, 1,000 fighter coins, 10,000 fighter coins, or 100 fighter coins as well. So what we'll do here, we'll create a function for that. So I'll name that function get balance address. I'll pass an argument address, so address, and just so what I've done here is that I've written the function name. I've passed an address parameter here. So now let me initialize this balance equals 0 here, and so my balance is currently 0, means at the starting it is 0. As every wallet you have created, the balance in the starting would be 0 only. So that's not for a case here. So let me loop over all of the blocks. So constant block, of this dot chain, and here, now after I loop all of the blocks of this chain, so there will be another loop, so that I'll loop over its transactions. So trans of block dot transactions. So as you can see, this is an nested for loop. If you know, you know. So after this nested for loop, what I need to do here is that I need to check the conditions. So let's say if I am the from address, I am sending to my friend. So from address is mine, to address is my friend. So if I am the from address, so my balance will get reduced. To address, if someone is sending to me, then my balance will get plused. So what I need to do here is that I'll create an if condition here. So if trans dot from address equals address, so the address that I've passed above. So what I need to do here is that I'll I'll decrement the balance, means I'll minus the balance that is there with me. So the balance will be trans dot amount. So the amount that is been transact, I need to minus it from my balance there. And after this, the second condition, the second if condition would be that trans dot to address. So if I am to address, then what I need to do here is that I need to plus my balance. So plus equals trans dot amount. So here as you can see, so for loop, in that for loop I'll first loop over every block of the chain. Then after looping over every block, at that time only I'll loop over every transaction of that chain. And if that transactions I am the from address, so what will happen, my balance will get reduced, and if I am the to address, then my balance will get added. So after this is done, after this all looping thing is done, then I will just return my balance, current balance that is calculated. So here my balance is 0, but after this my balance would get added or it would get reduced as well. This get balance address, we need to check our cryptocurrency that it's working and all of the transactions are working. So what I need to do here first is that I need to create transactions. So let me just create transactions. So fighter coin dot create transaction. So as I'll leverage that function here now, and I'll initiate the transaction, new transaction, and in that new transaction, what I need to do here is that I'll pass fake addresses as strings. So address 1, and then I'll pass another fake address as address 2 here. So address 2 here, and then how many coins I'm going to transfer? I'm going to transfer, let's say, 100 coins of fighter token, and then this is my transaction created. So I'll just copy it, then paste it, and now from address 2 I'll pass it to address 1, and let's say I'm going to pass here only 50 of my tokens. So what happens here is that these addresses that you're seeing as string here will be the public key address of your own address in the real world blockchain, but as it is implication of a real world blockchain, so we are not going to use those public keys, as they are just ridiculous to see and they are so big hexadecimal numbers that nobody can understand them. So yeah, now let me console.log miner, because These are just transactions that are going to in the pending transaction tab, and we want to mine our own block as well. So now let me just do that in a new line. So, and I'm going to write the starting the miner thing, and now after writing that, let me just mine the pending transactions. So fighter coin dot mine pending transaction that I've created above. As you can see here, mine pending transaction, it will take an argument that is the address of the mining reward address. So I'll create a fake address here as well. So let me create that. I'll write the, let's say, academy address semicolon here, and then I'll console dot log this feature as well. So console dot log and /n balance of academy is, and comma here. So now let me just phytocoin dot get balance address, and let me pass in the argument as academy address, and then after that a semicolon. So let me just first take a look at my code and see everything is correct or not, then we'll move to the terminal. So guys, let me just run my file. So node main.js and hitting enter, starting the miner. So my block is mined successfully. I'm so happy guys, I'm so happy. Then block successfully mined, but what is this? So balance of the academy wallet that I've created is 0. So is it false or my code is incorrect? No, it is correct. What happens here is that you get your balance of when you mine the next block. So here I'll get my mining reward, but I will get the mining reward after the next block is mined. So what we'll do, we'll just mine the next block as well, so that we don't get any problems here. So mining next block, and let me write here again. So again, and just let me save the file and open up my terminal. So after opening up my terminal, let me just write node main.js, and okay. Now you can see that block mined, starting the miner, successfully mined. And here I've forgotten one thing, so sorry. So copy this line of code as well, and just uh, take my address. So now let me run it again. So node main.js, and now as you can see that it's successful and I've mined it successfully, and I also even got the rewards. So yeah, this is how your cryptocurrency is created, and this is a simple cryptocurrency in the JavaScript. And hope you like the video and you learn more from it in the coming near future. And if you want some fighter coins, I'll send it to you as well. After finishing our module 1 and module 2, now we are heading towards module 3 of this course, which is the last module of this course. Basically, it is the smart contracts intuition. So let us now learn what is Ethereum first, and after that we'll learn what is a smart contract and so on and so forth, guys. So what is Ethereum? So you might be thinking that who's this man or who's this guy? His name is Vitalik Buterin. Vitalik Buterin was a founder of Ethereum. He founded Ethereum 2013. He actually is a founder of Bitcoin as well, but due to some change in mindsets, he founded his own cryptocurrency named as Ethereum. So the ticker name of Ethereum is ETH, means the token that uses Ethereum is Ether. He founded Ethereum. Ethereum is basically the programmable money in the blockchain. I personally find Ethereum very, very interesting than the Bitcoins and all of the other cryptocurrencies that do nothing, but Ethereum is more powerful, more developer friendly, as you can build your own dApps on the top of Ethereum virtual machine. So yeah, let's take a look at what's Ethereum. So what's Ethereum? Ethereum started with a notion known as code is law. That's true. I also believe that code is law. Ethereum is a network of the hundreds and thousands of computers, making it a very giant supercomputer. Ethereum's whole and sole purpose was also to become a supercomputer. Ether is the native cryptocurrency on the Ethereum blockchain, as I've told you. Ethereum is the programmable money of the blockchain. You can program your money, means the Ether, via the Solidity programming language, which we'll be using to deploy our first smart contract later on in this module. So what is a smart contract now? I think so that it will make you a little more curious about what is a smart contract and why do we need to think all of these. In 1996, Nick Szabso named the term smart contracts basically as a set of promises that are specified in a digital form and executed in digital world only. This was not possible at that time but is now possible through the blockchain technology. So a smart contract is a computer program working on top of a blockchain which has a set of rules, conditions based on which the parties of the smart contracts agree to interact with each other. So you might be thinking that what is it? Let's say I programmed a smart contract and stated some set of rules that after I turn 25 years old, after 6 years, that after I turn 25 years old, I will recover my 100 Ethereum tokens or Ether tokens. Till that time, I will not receive my token. So I have to build a smart contract. I have to put it on the Ethereum blockchain, which is the EVM compatible chain, and the smart contract will be constantly running. And when I turn 25, at that time, I can go to the smart contract, sign into my MetaMask wallet, and I will receive my 100 Ether tokens. So smart contracts are fully automated and digitally stored, means nobody can start or stop the smart contract. Once it is deployed in the Ethereum blockchain, it is running forever and ever and ever. After I received my 100 tokens as well, if I don't put a function name as self-destruct, the smart contract will be there forever. And it is digitally stored, means no physical appearance of the smart contract is created. It is digitally stored forever and ever in the Ethereum blockchain. Let me give you a more robust example on how smart contracts will change your life. So what happens now? Let's say Alice is a buyer of a real estate. So what is the process that Alice needs to do? First of all, Alice needs to have the money or needs to take a loan from a bank. Then then Alice needs to take the deeds of the house and run through lawyers, brokers, insurance agents, and many more people to get the deal done. After that, Alice needs to transfer the money to the seller, and the seller signs the contract, and then got his Alice got her house. While in smart contracts, that's not the case. Let's say Bob is the seller. Bob makes a smart contract that anyone who who is likely to pay the amount that Bob needs. Let's say Bob needs $1 million for his house. So he coded a smart contract wherein in which if you have $1 million in your MetaMask wallet, just go sign it, just go connect your MetaMask to that smart contract and purchase that house. So that's so simple. And code is law because of the blockchain, because of the what you've learned in module 1 and module 2. Now you'll apply here in smart contracts. So blockchain will keep the transaction history, the data. Everybody in this world will know that Alice owned that house. Moreover, Alice can pay in the Ethereum tokens, that is a native cryptocurrency of ETH. Alice can pay in the Ether tokens, that is the native cryptocurrency of Ether. This is so simple process to buy a house nowadays or through smart contracts than it is through the earlier processes. So working of a smart contract, how does a smart contracts work? So here's the same example, but a little more easier way so that you can understand it easily through looking. So Bob wants to sell this house, matching of buyer and selling. John wants to buy the house. So smart contracts receive the assets, means the house. Then what happens? Automation of clearing and settlement through cryptocurrency is happening. Land deed is digested and the ownership is transferred to John, which is very simple and easy process, and it can be done digitally as well if you know the condition of the house, and furthermore the price and negotiation is not being happening. Smart contract not only have these use cases, but it has more of a use case like the dApps, decentralized applications, which is more appealing to the end user, which is going to use dApps in the near future. So what are dApps? So dApps are basically the digitalized applications or programs that exist and runs on blockchain or peer-to-peer network of computers instead of a single computer. Let me give an example. Amazon, Facebook. Facebook uses a server. What happens? Facebook has a centralized server, while in the dApp, it would not have a centralized server. Every computer or node that is participating in that network has the ledger, which is used in the dApps to provide the server side of the dApp. So dApps can be developed for a variety of purposes including gaming, finance and social media as well. So here you can see that apps have a data center and they provide the data to everybody. While the dApps do not have a single data center, they are stored on the Ethereum blockchain, which is basically a public blockchain and everybody has a copy of it in their own computers or nodes. So let me give you some alternative to apps so that you can easily memorize or think the real world uses of dApps. So apps, YouTube, there is a dApp named DTube, Instagram, Decentagram, Google Chrome, Brave browser, Zoom, Brave Talk. Let me take you to some of them. So here you can see I am in my Brave browser and the UI UX is very simple, very easy to use, and here there are many more things that I can ever imagine. So here you can see behind is a cute little photo that is matched by myself. Here is a trackers and ad blockers, bandwidth saved, time saved and all those stuff. Here are my favorite tabs that I have been visiting lately. Here you can see there's a Brave Talk, which is an alternative to Zoom. You use Zoom for many online purposes, for learning, for attending your lectures, for meetings and all those stuff. So now you can just use Brave Talk, which you can access from your browser only. So you don't need to take tension of installing the app and all those stuff. While you might know that in 2020, when Zoom was being a bigger hit, what happened was that Zoom had many issues in the network. The data that Zoom had were being sold in the dark web for just free, and you might not think that it was very harmful because Zoom had all of your data, like what are you talking, what's the meeting about, how long was the meeting, what are your email IDs, passwords, your banking details, if you have taken a Zoom Pro version. So that was a big hassle. But in Brave Talk, as it is decentralized, so there is no chance for your data to be sold, and you can control your data while going in about your data and in this Brave browser as well. I need to give you some insights of what this Brave browser is. So first of all, here is a Brave rewards tab. What happens here is that you can just block the ads that you are seeing on Google Chrome. When you use Google Chrome, guys, you are served with ads, and that ads you are not paid for. Only the Google that is showing you ads is getting paid for, while you are seeing the ads, so you need to get paid as well. What happens here is Brave gives you the right that if you want to see ads or no, if you want to get an extra earning. I have been using Brave browser not that much. I'm not telling you a lie. There is nothing to hide because I have many of my passwords saved in my Google Chrome, and I cannot shift it from Google Chrome to Brave browser, so I am stuck in Google Chrome. Lately, that's sad. But here you can see that I have used Brave browser for quite a bit, and now I have 1.750 BAT tokens. What are BAT tokens? BAT tokens power the Brave browsers and the Brave talks. People are thinking of it as the future cryptocurrency of Google Chrome alternative as well. So here you can see uh, my May earning was 0.09 BAT, while my June earning is around zero point 0.8 bats. So this is a very great way of earning. Here you can see I have my wallet as well, which is also known as a Brave wallet. It is secured. You just have to type your password and click on the unlock button. So you'll get access to your Brave wallet. Here you can see it is here I have a MetaMask wallet as well, linked with this Brave browser. So I have shown you many of the dApps, and you can also now use these dApps and share your experiences with your friends, family, and relatives. So, after seeing the dApps, what you will think that if there is no governance, how we will run these big apps like the social medias, like the Facebooks of the Web3, the Instagrams of the Web3. So here comes a thing known as a DAO. DAO is basically a decentralized autonomous organization which is community-led entity that has no central authority. Means it is fully autonomous and transparent. Smart contracts lay the foundation rules, execute and agreed upon decisions, and at any endpoints, proposals, votings, and even the very code itself can be publicly audited. It is everything is public. Anybody can take a part in DAO. So what happened in DAOs is, guys, that you take a part in a community and you have a voting right. You have a power. th- Everybody has a power in that community to vote, to propose to something or the other. Let's say you are the CEO of a big company. Yeah, so there is no CEO in decentralized natures, but there are DAOs. So here you can see traditional top-down images. So it is not that clear. So first the position is of CEO, then of the top management, then of the middle level management, then of the lower level management, then non-management staff, and the lowest management staffs, janitors and all those peoples. But in decentralized autonomous organizations, there is nothing like that. People are interconnected through blockchain. People have laid the foundation of DAOs through smart contracts, as you know. So everybody is control over their own data, and everybody is the CEO of the company. So here you can see that there are developers, miners, users, and the exchanges. So these all four people are interconnected, and they form the DAO of a community. So Ethereum DAO election is explained very easily. So let me tell you that you can hold your country elections through blockchain as well. Here is how Ethereum has proposed it. Let's say a country holds an election and wants to prevent fraudulent voter fraud. What is a voter fraud? Let me explain you that. It seems that people always blame Indian voting systems that they are very ill treated, they are being hacked, they are being changed, they are being manipulated. So that's the voter fraud. One person cannot vote one time, more than one time, while. So what happens to safeguard through this process? A DAO is created which is transparent and eliminate vote rigging. So there are some condition sets into the code which is embedded. So let's say only a person can vote once. The election is won when a party acquires a decent percentage. One needs to hold the country's citizenship as well. So what happens after the code is written? The voting tokens are issued to everybody eligible to vote. They cast their vote. Every vote is recorded in the blockchain and it is immutable, as you know, through the immutable ledger. It is transparent, means everybody can verify it. So this also removes the voter fraud system and the security feature from it, and it can also be run by itself and it is decentralized. I believe that every coin has two sides. So if it is very good, there will be vulnerabilities, there will be mistakes, there will be some sort of things that you need to learn from. So this is a learning I'm going to tell you about the DAO attack. So what happened? DAO failed. When it failed, on the very first beginning on Ethereum, when DAO was proposed in 2016, one of the ICOs of the investment funds on Ethereum collected 11.5 million ethers, now worth more than billions of dollars. What happened? Smart contract was not properly audited by Slog.8 so the creators of it. As a result, there was a critical money drainage bug. Find the bug and cause that bug to loophole. And all of the money was drained from this attack. While Ethereum to punish the attackers or scammers, Ethereum reversed this transaction through a hard fork that will be learning in future. So you can see that we have learned that the DAO attack has taught us that everything has a failure. You need to learn from your mistakes and go ahead and use things, make it properly audited, give time to them, and accept your mistake. So next is the soft and the hard fork. We'll be learning about it in a very short. What is it and how it will be useful for us. Ethereum in July 16 had this DAO attack. What happened is, let me explain you. On block number 919199999, what happened that Ethereum decided that it needs to hard fork Ether. That the DAO decided that it needs to hard fork Ether to transfer the money back to the investors of that ICO. So, after hard forking the Ether, the block started continuing to mine as it was usually happening. The transaction got reversed, everybody got their money, and the ticker name of Ethers was now ETH. What happened that some people in that area told that yeah, it's okay that you have lost money, but we want the older version of this software. We don't want to go for the hard fork. So what happened at that time? Soft fork also happened. So what happened in the soft fork? People did not change their software, and that created a new chain which is known as the ETC or the Ethereum Classic token. So you will find both of the tokens in the coin market cap section, and they both are just same. One is the hard fork of Ethereum in July 16, while the other one is the soft fork of Ethereum with the old version of the software. So what happens? Do you need to change your software, or do you need to go with the hard fork, or do you need to go with the soft fork? Well, in my perception, I believe that software needs to be updated timely, and hard forking a cryptocurrency is really good. And with hard fork, I remembered one more thing, that the hard fork of Ethereum is coming, namely the Pulse chain. As you know that Ethereum blockchain is now very congested, and the gas fees of the Ethereum and is as the gas fees of the Ethereum is rising to the moon. So to lower that burden, Ethereum sister chain is coming, which is also known as the Pulse chain. Richard Art is removing it. We'll talk about it later in some another video. So while talking about the hard fork, I remember that suddenly. So shared with you guys. So now let us talk about ICOs. What is it? Initial coin offering. While you might be knowing IPOs, it sounds similar to like that. So let me tell you. So ICO in the cryptocurrency industry is equivalent to the IPO. IPO is basically that time of period when a company decides to go public and takes public funds from the open market. A company seeking to raise money to create a new coin, app, or service can launch an ICO as a way to raise funds as well. So, how does an ICO offering work? What happens is, first pre-announcement happens. So, early announcement of the procedure is made among the cryptocurrencies investor to make the hype. Offering. So, an offering is made that, let's say, if you participate in the ICO, you will get 10 tokens, you will get 100 tokens, you will get 1000 tokens. That PR campaigning is being done, means marketing is done of that ICO to get more and more users on board, and everybody and anybody can get into ICOs, not a condition like IPOs where you need a PAN card, you need a bank account, you need many other stuffs. So yeah, ICOs are just the case. And the ICO sale happens where the token is distributed among the investors, and the investors who have participated in this ICO want to get rich quick. Yeah, that's their mindset, but that's not the case. You need to check the ICOs, the companies behind them, and all of these things. I'll guide you in this step as well. Just watch it till the end. So ICO case study. Let me give you a brief introduction of what the successful ICOs were in the previous histories. So in July 13, the first ICO was launched, namely of the Mastercoin, which raised around a whopping $500,000. That is very great at the time of the July 2013, when people were not knowing about all of these ICOs, IDOs, IEOs. I think most of the people just took a punt on this Mastercoin, and Mastercoin was able to raise $500,000. While in April 2014, not past just 7 or 8 months, there was another round made safe made, and it was able to raise $7 million. That's a great jump from $500,000 to $7 million. While Ethereum also did an ICO in July 2014, and it was able to raise $18 million from the investors. So Waves also did an ICO on June 2016, and it raised around $16 million. The DAO April 2016 $150 million. Qtum $15.5 million. Gnosis, it raised $13 million in 2017 of April 24, while the status token was about to raise $100 million in June 2017. Banker $156 million in June 2017. Tezos $232 million in June 2017, while EOS was about to raise $185 million in July 2017. What happened is that in 2017 the ICO was busted and people got to know that these are quick money schemes which the founders of the tokens are using it to make pure money, and they started removing their money and the market crashed. That's all for the beginning of the ICOs. Now ICOs are happening, and let me tell you and how you can find ICOs and the ratings on ICOs and all of these things. ICO launching sites. The first one is a coin factory, second one is a token get site, and the third one is a block starter. So you can visit these sites whenever you are free, jot down this site's name, and whenever you are free, you can just visit these sites. These sites will allow you to launch your own ICOs. While if you want to become an investor, you need to see the ICO listing platforms. The first one is the ICO drops. So whenever you are free, jot down these name of the websites. You can visit these websites to see the new upcoming ICOs, ICO bench and coin schedule. So you'll go in the website, you'll visit them, you'll see some names of the tokens, but you'll not recognize that. How should I recognize the bad ones with the good ones? So let me help you in that as well. So blockchain startups white paper analysis. Now today I'll be giving you an analysis of how to analyze the white papers that the founder is showing you. So first of all, let me tell you, if you're feeling that that startup is just too good to be true, or that the returns they are telling or the promises they are making are just too good to be true, or they cannot be easily digested, don't invest in them. Please don't invest in them. The first is the quality of the white paper. Quality here means that how clean it is, how short it is, and how well managed it is. Company information. You should always look, if a startup is launching a white paper, is there a company behind it? Let's say tomorrow Amazon tomorrow Amazon removes its Web3 version and started its ICO. Anybody will trust that ICO and will take in part because Amazon has its own backing to that ICO. So that's the company information. While it is not necessarily needed, because these are just startups, and people those who are investing in these startups know that eventually their money is going to go down only. Next, you should see in the white paper that what's the problem they are solving, the solution and the benefits they are providing, the products and the services they are going to offer through this startup. Market competition. Is there any other player in the market that they are going to compete with? Do they have any moats? Moat is basically a term where they have their own business competitive advantage. The ICO team, the team behind this is very, 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 very important. I am purely emphasizing on the teams while you consider the blockchain startups. Tokenizations. How is the tokenomics? If the tokenomic is unlimited, then if you ever take part in the ICO, then only God can save you. Roadmap. See, roadmap is very, 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 very important in the white paper, because you need to know that the team or the developers that are behind that project really know where they are going to head. Because if they don't have a roadmap, they are sailing on a ship that doesn't have a steering wheel. Legal aspects. They requiring your KYC, because some countries require your KYC, and legal aspects also reminds me of that there is no legal entity bounds in ICOs, so anybody in any area can participate in ICOs even with very little money as well. So if I want to take a part in the ICO that is based in the USA, I can do it very easily. While if I want to take a part in the IPOs that is of the US company, it is very difficult for me to do that. So guys, as I have been talking about white paper, so let me take you to the greatest white paper of all, which was introduced in 2009, the Bitcoin white paper. So Bitcoin, a peer-to-peer electronic cash system. So here you can see that Satoshi Nakamoto, who has basically published this white paper, has showed you how the transactions are working, how the timestamp worker is working, what is proof of work, what is the network, incentive, reclaiming disk space, simple payment verification, combining and splitting value, privacy, calculations, and many more. Here you can see that it also contains the code, which is basically in the Python programming language, which we have also made in our own blockchain, so you can relate to it. So here is the conclusion. So this is the electronic cash system which you can rely on without trusting each other or without trusting any third party person. Let's say a bank that it backs the value of that money. This is a Bitcoin white paper, the oldest of the white papers, but now as we are moving further, we have many new white papers. So let me give you a glimpse of all of them. So this is SIA.tech. This is a decentralized data storage system where you can store your data in this blockchain in a decentralized manner, like the alternatives of the Google Drives. So here is the basic white paper of SIA. So let us look at it. It was introduced 14 in November 29. So here you can see the abstract, the introduction, the general structure of the blockchain, how the transactions are going to work, the signatures, file contracts, because basically the file is only going to be stored in this blockchain in a decentralized manner, proof of storage. This will use a proof of storage like we know basically proof of work, proof of stake, delegated proof of stake. Here it is proof of storage as well. As we move further, there is arbitrary transaction data, storage systems, client protections, basic reputation system, SIA funds, and the conclusion. So, so this is how a blockchain white paper should look like. This is how you should identify your blockchains white papers. You as an investor only have the white paper to look at, and you as a founder of a blockchain startup only have one way to communicate, is that with the white paper. So let me take you to very interesting Web 3.0 game, namely Axie Infinity. Many of you might know this, many of you might not know this. If you don't know, this is a game which is a Web 3.0 game which is blockchain based, and here you can play and earn rewards as well, which is real world money in crypto. So here you can click down your white paper and you'll be redirected to this website. So this is the official white paper as the name suggests. Here you can see Axie Infinity Universe. This is a more simple way of creating a white paper. Here you can see the gameplay tabs. You can play games. You have to first collect NFTs, which are Axie Infinities. This is like the Pokemon game. Like when I was small, I used to play this Pokemon game where you used to find those Pokemons like Pikachu, Raichu, and all those. And here it is the Web 3.0 game that replaces that Pokemon. So here you can see that in the gameplay you can battle with others to earn rewards and to win the game as well. Breeding and SLP. When you breed, you get SLP token There is smooth love potion token. You beat 0 from 7, and if your breed number is 1, so the SLP cost per parent would be 900 SLP tokens, while 1 upon 7, the breed number 2 SLP cost per parent would be 1350 tokens, while 3 it will increase eventually and the end is 15,300 tokens. Here you can see there are many genetics in this Axie Infinity. You need to get the rarer one to earn more of the rewards. So yeah, this is how this blockchain white paper looks like. It is very appealing to a normal investor and to me as well because it is really good. So what happens? Players this play and spend and earn in Axie token. Axie token is basically a governance token, staking token, and a payments token. So you can stake and earn rewards in this Axie Infinity tokens. While governance token, if you hold this token, you are a part of that DAO that I have explained you earlier. You also get rewards when you just take it and you can just play it and you can just play with this Axie Infinity tokens. Last but not the least topic is the blockchain and Web 3.0 space. So Web3 is a representation of the next generation of the internet, one that focuses on shifting power from big tech companies to individual users. So what happens now is that the big tech companies like the Googles, Amazons, Facebooks of the world have more and more of data that you can never imagine of as well. It can serve you ads on that data, it can sell your data. That is the breaching of your privacy, and these know more about you than you also know about yourself. So people have taken an initiative to shift from Web 2.0 to Web 3.0, and what it makes so unique about Web 3.0 is that it is a peer-to-peer network, means everything is on the blockchain, so everybody can verify it, transact through it. It is immutable, everybody can use it. 3D graphics mean you can easily design a UI UX on top of the blockchain. What happens that in enhanced connectivity, let's say Amazon server is wrecked. Amazon server is very slow. So if you wanted to make a call from that server, the server is in maintenance. How can you make that call? So what happens here is that if you have it in a digital peer-to-peer network, so let's say there are four peers, peer A, peer B, peer C, peer D. And in peer A, there is some problem in the computer while you still have access to three peers, peer B, peer C, peer D. You can take from any one of them the data because the data is the same and you'll be good to go. Artificial intelligence. Blockchain and artificial intelligence can combine and make wonders to this world, guys. So let me tell you some trends. What is Web 1.0, what is Web 2.0, and what is Web 3.0? And you might be thinking, why are we learning about Web 3.0 directly? Why not Web 1 and Web 2? So let me give you an overview of what I am telling. So Web 1.0 basically was the read only websites, means you can just read from the websites, not put anything, not write anything. These were the times of the early 2000s, while Web 2.0 is basically that you can read also and write also from that website. Let's say you can sign in with Google, sign in with Facebook, sign in with Twitter, which have your email address and password already stored in within them. Web3 excites me because it is actually taking the control of from the big giant tech companies and giving to normal users. So you can just connect your MetaMask wallet, your Phantom wallet, any of your wallets that you're using, and you can use the Web 3.0 services. So last but not the least, let me give you a comparison of what the Web 2.0 apps are there and what Web 3.0 dApps are there. So browser I have given you already. Google Chrome has the Brave browser. Storage, Dropbox. Google Drive, they are being changed or replaced by star J and IPFS. Video and audio calls, so normally we use Skype, but in Web 3.0 dApps you can easily use Experty. Operating system, there is Android and iOS, while in Web 3.0 dApps there is EOS and Essentia.1. Social networking sites, here we have Facebook and Twitters, while in Web 3.0 dApps we have Steemit and Akasha. Messaging apps, here we have WhatsApp, Messenger, Telegram, all of these things. While in Web 3.0 dApps we have status, and now only it has been removed block scan chat by the Etherscan team. So what happens in that, you can easily talk to a person whom you have done the transaction through that block scan chat. Remote job, first it was up, now it has ethlans. So this comes to an end, guys, and hope you've liked this module 3. Now we are going to deploy our first smart contract, and after that we'll be done with this course. So hope you all know what is a blockchain, what is a cryptocurrency, and what are smart contracts, and how this blockchain technology will change our whole world, guys. So now we are going to deploy our first smart contract from the module 3. So let's get started. I am here in my Brave browser. You have to just go from this to this website, Remix IDE. Search it on the Google and you'll get this remix.ethereum.org. Just click on it. The Remix IDE is going to open. This is an IDE which lets you to deploy a smart contract very easily from your own browser. So this is a starter. Welcome to Remix ID, Solidity compiler, and deploy a smart contract. So if you want to deploy a smart contract on EVM compatible chains, you need to learn a language named Solidity. So what is Solidity? Solidity is a object-oriented programming language which highly resembles Python, C++, and JavaScript. If you know any of these from these three, then you're good to go. If you don't know, don't take tension. It's very easy. You can learn it easily. If you know Python, then it's very easy for you to learn Solidity. Without going into further details, let me tell you how we will deploy our first smart contract. So here you can see that you can create a new file. Just click on it. Just write the file name. Here I will write hello world.sol. So Solidity comes with a extension of .sol where you can easily find that this is a Solidity file. So what happens here, that you need to tell Solidity that you need to initialize Solidity with a statement that is known as a pragma statement. So here you will write pragma Solidity and you need to hard code the version that you're going to use. So for security and safety purposes, I will use 0.8.8 because it is the most stable version I've been using till now. So now, if you want to initialize your smart contract, you will have to use this word contract, name of the contract, which I'll put hello world, and try to use the word of the name of the contract that you have named it. Like you can see that I have named it here hello world.sol. So you have to name the contract hello world as well. So now you can see that I have created a contract, an empty contract of hello world. So let me compile this. You have to compile it with Control S. Now you can see that it is giving me an error. So I know that this error would have might been come. So this error is basically the Solidity compiler error. Here you can see that it is 0.8.7, but here I have hard coded 0.8.8. So it is giving me an error. So don't take tension. We just need to go here and change it to 0.8.8. And now if I hit Control plus S, and that error is basically gone. So here you can see that now it is successfully compiled, but I am getting another error, which I was expecting this error only from the previous one. So this is the license warning, actually not an error. So warning is basically that if you don't follow it, it's okay, but for a safer side I will follow it. So for you to understand, so you just need to comment it out. So to comment you need two forward slashes and then control plus V spdx lighter, and you need to write here unlicensed. So now let me hit control plus S again, and here you can see I've got a green mark, means this is successfully compiled. And now if I want to deploy this contract, so here you can see I've deployed this hello world contract, and this is the simplest smart contract you can create. Yes guys, this is the simplest smart contract. Now let me change something here. Let me return hello world when I deploy the smart contract. So what I'll do here is basically I have to declare a string that is named hello world. So how will you do that? So you'll explicitly type string, as it is a lower level language string, and you need to make it public, the visibility of this variable, and you'll name the variable, let's say any variable you want to name. I will say greet. So this is the name of the variable, and here I will hard code hello comma world, and don't forget to put a semicolon. If you don't put a semicolon, it will give you an error. Control plus S, crossing my fingers, and here you can see I've got a green checkbox, means everything is very grateful. And I forgot to tell you what is this deploy and run transactions part. So here you can see your environment should be JavaScript VM. You can go for injected Web3, but in that it will ask you for your MetaMask. So that is not in your course right now, so just go for JavaScript virtual machine. Remix give you tens of IDs with 100 ethers each. Test accounts, these are all test accounts. Don't feel that you are now rich because you can't do anything with them. Instead of practicing of the smart contracts, this is the gas limit. So gas limit is basically that limit that you pay to the miners to run the smart contract for you in the Ethereum virtual machine. Here is the name of the contract, the which contract you want to deploy, and here is the deploy button. So when I'll click the deploy button here, you can see this contract is successfully deployed, and here I can see in the terminal that it is deployed. Here I can see the transaction details. So let me show you the transaction details. Status is true, means transaction mined and execution succeeded. So that you can see the transaction hash here from, that is this address that I've been using. 2, this is the constructor of this hello world, gas that has been used, transaction cost, execution cost, the input, the decoded input, the decoded output, the logs, and the value. So you don't need to go in all of these low level details now. Let us just now focus on the hello world part. So here you can see I've got a blue button here. When I click that blue button, let me see what magic happens here. So when I click the blue button, a transaction is called. That variable that I've put it here named greet is called in the form of transaction, and it returns me the string named hello world. So here you have seen that I have successfully deployed my first smart contract. But to make it more interesting, and as you have been enrolled in this blockchain and cryptocurrencies course, let me tell you that how you can create your own token. Yes guys, you can also create your own token. So let's get started. Let's build our own token. Let me name that token Fighter Academy token. So let's get started guys. So here you can see we'll create a new file, and I'll name that fighter token dot soul. So here you can see that I have created a fighter token. Let me just import the first two lines from this previous code because I am very lazy and I don't want to type all of this again. So yeah, I have imported it. And here you can see I've imported the pragma statement as well. So now I'll initialize the contract fighter token. And what we'll do before we start writing in this program, we'll import here with the import keyword and just copy pasting it. After that, you just need to give a semicolon. That's it. Now what we need to do, we need to define some functions and declare some functions here so that we can use them easily. So I'll start with the constructor function. So in constructor ERC20, and I've forgotten one thing. Here you need to write that contract fighter token is ERC20. So let's get started here in this ERC20 part. I'll close and open and close parentheses. Then I'll write my token name here. So what is my token name? So my token name is, as I remember, it is the fighter token, while the ticker name means how it will be called. Let's say for ethers, we used to call it as ETH. So it will be called as, let's say, FGT. Basically, what is this constructor function? So we need to initialize some of the things in this constructor functions. Let's say the mint function, mint underscore mint. So it is easier and it is more useful that you initialize new variables, private variables with an underscore so that you understand it. So mint function needs to be initialized an address and the amount that the person is going to be minting those tokens. So let me give you another new variable which is a global variable, msg.sender. So what does msg.sender do? It is a global variable which is defined by Solidity itself. So what happens here is that whoever deploys this contract is going to be the owner of this contract, and that owner is named as msg.sender here. So what happens here is that I have given an address. Now I have to give the initial supply of this fighter token. Let me give the initial supply of the fire tokens as 100,000 tokens. 100,000 tokens. To give it to the decimal points of 18, so I need to multiply it by 10 to the power 18 and give a semicolon. Now function has been initialized. Now I have to write more functions, two more functions, and basically we are good to go. So the function mint, so you need to declare a function by the explicit name function, and here I am writing mint. So what this mint will do, mint will take two arguments, an address that is I am transferring to, and the amount that I am transferring to. Uint amount. Uint means unsigned integer. This would be external. So here you can see I've described a function named mint. It takes two arguments, that is the address to that I'm going to send my just mine tokens and the amount that I'm going to send to that person as well. So I need to again define it as mint and just need to pass two things, to and amount, and with a semicolon. But there is a bug here. What bug is here? If you can understand it, then it's very great, but if you can't, let me help you. what happens here is that anybody can mint any amount of tokens here, and it will cause higher and higher amount of inflation. Thus this token will lose its value eventually. So what we need to do, see, anybody creating a token does not want that its token loses its value over time. So what we can do here is we can basically declare a variable. So address public admin. So we can declare admin here, so that nobody can create any amount of tokens they like, only the admin can create it. So admin equals msg dot sender, means who's the admin here. I am not hard coding the admin with that, with my address. Let's say if I wanted to hard code it, what would have done is gone into this tab, took my Ethereum address, copied it here, and just pasted it here. But I don't want to do that mistake. Let's say I'm building for someone else and I want him to be the admin, not me. So I need to pass here in this mint function that a require statement, require msg dot sender equals admin. So I'm giving a condition here that the msg.sender should be the admin, and if not, then I'm going to give an error message that's only admin. Nobody else should be allowed except for admin here. So I've created a function mint. Now I'm creating a function burn. So let's say if anybody has extra tokens, so they can burn their token to reduce the supply of the tokens and eventually increasing the price of the tokens. So you will not need any of the addresses here. You only need the amount, how many amount of tokens you need to burn. So this will take only one argument, and this is also external. If you don't want to write external, you can write public as well, that's one and the same. So what we'll be using here is burn variable. This will give us outputs, namely the msg.sender variable, message.sender, and the other one would be the amount that we are going to burn. So I think so that we are good to go, fingers crossed, because you never know what a code can do with you. So let it compile. I'll let it compile, and here you can see I've got a green tick mark. I'm more than happy now. So what I'm going to do is here I'm going to check that this is my account which I'm going to deploy this contract through, and here is the name of the token. This is a fighter token. So I'll first clear this mess up here of the hello world, and just going to deploy this token here. Sorry, just going to deploy the smart contract here, and here you can see many many functionalities here. So let me first give you what is the admin. So when I'll click admin here, there is another call from the transaction, and you can see my address. My address means this test address that remix has given to me, 0x5b3. So means this contract is working. When we have imported this contract in front of you, even though we have not defined all of these functions, we can still access to them. So let me give you an instance that if you see a orange button here, you can modify data from here, and if you see a blue button here, so you can only access data from here. So let me access the name of my token, which is namely the fighter token. Let me access the symbol of it. Let me access the total supply of it. Now you can see that the total supply is so much. So don't take tension, because it is the 18 decimal and it shows the decimal as well. So it is only just 100,000 tokens that I have showed you before. So the decimals it 18. So now let me get the balance of my address that I have deployed from it. So this is my address that has been deploying this contract and is the owner of this address. So let me paste it and balance off, so you can see The whole balance is with me. So I've minted this token successfully. So now what I will do is I will just transfer all of these tokens to, let's say, my second and third addresses. So for remembrance purpose, I will just go it give it to second. So what I will do first, I will paste my address in this transfer function, put a comma, and then copy this 100,000 tokens and just paste it here. Then I'll click on the transfer button and oh, what? What happened here? It is showing a transaction failure. Let me have a look at it, what mistake I've done. So it shows that ERC20 transfer amount exceeds balance. I must have done some mistake. So yeah, I've done the same mistake that I need to go to my original address, that is the msg.sender that has this tokens with them. So now if I click the transfer button, it will be successful, hopefully. So yeah guys, it is successful and I've transferred all of my tokens to this address. Now what I will do is I will just go above, copy this address again, go to my initial address, and now I will paste this address here to see the balance. Okay, now let me see the balance of the same address first. It will be 0. Let me go to paste and then it is the same 100,000 tokens. So here we can play it all day long to just remember and see all of these things. So now let me burn some of my tokens. So how will I burn it? So first let me transfer the tokens from this address to the original address. So let me go to this address. Let me just first let me copy my original address, that is the first address. So I've copied it. Then let me go to transfer and let me back and paste it. Let me put a comma and now I'm going to transfer all of my tokens from here to my original address. So transfer, I'll click the button and it is obviously successful here. So now let me get the balance of this. So it is 0. So now I want to burn, let's say, half of my tokens. So what I will do, I just need to make sure that I am on the correct address. So I'm not. So I'm going to end up in my correct address. So I need to take that supply. I need to copy it and I will paste it here. And just to half it, what I need to do is I need to go here, cancel the 2 and just write 5. So now we will click the burn and the transaction is successful. So well, you might not be thinking that how is it successful. So let me show you that. I will copy it and paste it here and balance off. So you can see that the balance remaining is only half of the tokens that were there previously because I've burnt half of my tokens. So this is so easy and so user friendly. Because of the remix, anyone can make any of their tokens from anywhere in this world. So I hope you have learned blockchain technology, going deep down in the roots. I hope that you'll learn more of this technology, curiosity, and I hope that you become the master of this technology coming forward soon. So here is the end of the course. We have completed all of our modules, module 1, module 2 and module 3 successfully. So hope you liked this course and you'll get some benefit from it. So yeah, goodbye. See you next time in another course or in another video.